A photo from NASA's website could possibly prove the theory that the Apollo moon landings were faked and were fabricated on a film set.
The earth is full of the goodness of the Lord. By the word of the Lord were the heavens made, and all the host of them by the breath of his mouth. Let all the inhabitants of the world stand in awe of him. For he spake, and it was done. He commanded, and it stood fast.
Conspiracy theorists claim to have found evidence that one of the moon landings was faked, using a photo from NASA's official archive. The photo was shared by YouTube user StreetCap1, and it shows an astronaut. The reflection in the astronaut's visor shows the figure of a person. There appears to be no backpack on this person, suggesting that he might not be wearing the full NASA spacesuit. So what are the conspiracy theorists trying to say? This reflection may or may not show a stagehand on a film set. Even distortion caused by the shape of the visor should show a backpack. Plus, where's the reflection of the person who took the photo? Back in 2009, there were some disputes over the legitimacy of the photos from this particular moon landing. So what do we know about the Apollo 17 moon landings on December 7th, 1972? Well, we know that it was the last time anyone walked on the moon. We know that it was a three-man team that consisted of Commander Cernan, pilot Ronald Evans, and pilot Harrison Schmitt. Andrew Cernan was the last person to walk on the moon. We know that the United States government had motivation to be the first country to put one of its astronauts on the moon. Basically, the reasoning behind the conspiracy theory that the moon landings were faked is that the United States wanted to beat the Soviet Union and be the first country to put a man on the moon. This was known as the space race, and it occurred during the height of the Cold War. The theory even suggests that NASA got the help of acclaimed movie director Stanley Kubrick to stage the moon landings. Definitely some convincing evidence, guys, but I'm gonna burst everybody's bubble right now. If you look at the shadow of the reflection, it suggests that this person in the reflection is wearing a backpack. And where's the person who took the photo? It probably was the dude in the reflection. The theory that the moon landings were faked has been debunked time and time again, but I guess it's fun to keep it alive. As someone who spends a lot of time on film sets, there are almost never stagehands next to actors, and if there are, they're usually holding boom mics, and that person in the reflection most definitely is not. Alrighty friends, it's time to respond to some comments. Little Miss Metalhead said, "Can I be part of the potato family, Charlotte?" Of course, my dear, anyone is welcome. Jungler Rafe said, "This channel deserves more subscribers." I agree.
Dr. Hovind, thanks for your channel. It gives my family something useful to watch. My question is, did we go to the moon? Sergey, I've answered this a few times before on my YouTube, and yes, I believe we did go to the moon. I think there's no question the government would lie to us. That's never been an issue. But yeah, I think that was really legitimate. We did go to the moon. I don't know that all the pictures were legitimately from the moon, but I think we did go. Okay, what are your thoughts about not being able to cross the Van Allen belts? Yeah, I'm familiar with that. I taught earth science for years. I don't think I think they allowed for all that with the radiation, etc., with the shielding and stuff on the spacecraft, and I take the position they did go to the moon.
There's lots and lots of people who still believe that the moon landing didn't actually happen, and I kind of feel like we should get to the bottom of this and see if we can recreate the moon landing. Then maybe there's a possibility that that could have actually been done on a sound stage back in 1969.
That's right, from the lunar surface. Up now, and you can see the stars from the lunar surface. Beautiful, just beautiful.
There's lots of compelling evidence that the moon landing did happen. And there's actually a lot of compelling evidence that maybe the moon landing was staged.
So I've actually done a lot of research on this.
Going into your research, what were some of your doubts that it happened?
And I was confused about how they filmed it. If they were just stepping out, who put the camera there? But they have that completely documented. There was this guy, Stan LeBar, who invented a camera that was in the side of the lunar module. When Neil Armstrong was stepping out, he pulled a lever that flipped it open, and that's how they got his steps.
Sure, they filmed it, but to broadcast it live from the moon, that seems pretty difficult, especially using slow scan television, which is one image for each frame of video that they had to then send to Australia, which then had to be changed into broadcast format.
there's no wind on the moon, right? How come the flag is blowing in the wind?
Inertia, which is the force of like once an object is in motion, it remains in motion. So from the force of them putting it into the ground, that's where the movement comes from. And there wasn't like gravity or force in the atmosphere to like stop it.
A lot of people think that there was a version that was filmed just in case they weren't able to make it to the moon or land on the moon.
It makes sense that they'd have a backup plan because we had to show that we actually landed on the moon. We had to beat the Russians.
Yeah.
Do you guys want to get down to the bottom of this or what?
Yeah,
Let's do it.
The day has come. We're going to recreate the moon landing on this awesome soundstage. We got a pulley rope system hooked up. We have the harness, which is going to be used to pull me up like I'm on the moon's landscape, and it's going to be awesome. How do we keep the flag like in the motion that it looks like in the video?
Wire with a little bit of fan.
We got our flag right here, which will simulate anti-gravity. It's time to create the landscape of the moon.
I think just piling dirt is not going to work just because we're not going to get the detail and the shadows just from dirt. So what I'd like to do is still get some dirt and sand, but put it strategically in places and then use pieces of like rock foam.
Anything that we do end up having to do in post-production, we're going to try to do as accurately to what tools they had available at the time. So we're not going to use any CGI, we're only going to use very simple compositing tricks that are similar to what they would have been able to do at the time using front projection, which is what a lot of experts think was used to fake the footage. We're going to try to extend this surface in post to make it feel like there's much bigger moon surface here.
Okay, so we got the astronaut NASA suits right in here. This is about to be the ultimate unboxing video. Are you ready?
I'm so excited. Whoa.
Here's my oxygen pack so I can breathe in fake space.
That's super legit.
So I'm getting suited up right now. They're making sure I'm super safe and that I don't break any legs. Ugh. I feel like the belle of the ball. Oh my God.
I think this is going to work.
I don't know if this is gonna work.
I think the point will get across.
Okay, I'm just gonna kind of bounce around and just do it.
Oh my God.
Hey, Ricky, I think you want to move like you're in Jello.
Yeah,
like
move
you're in
slow.
Like you're in slow motion, kind of.
Slow.
Yeah.
It just takes a second. Okay.
Yeah, that's good.
So since we don't actually have two astronauts, we're going to take Ricky here. And we've already filmed him once doing the kind of floating motion. And now we're going to film him again on the other side of the flag as the second astronaut. And then we'll composite them together with a split screen.
Cool.
Cool. Let's do it. It's going a little bit too fast. Yeah, now you look like you're in space. What I'm doing right now is compositing using digital versions of the same techniques that would have been available to filmmakers at the time.
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface.
What conspiracy theorists say is that he's too well lit. You can see him clearly, yet he's in this black shadow of the LEM. There's only one light source on the moon. That's the sun. Conspiracy theorists claim there must be a second one making him visible, and we're going to find out.
And to do just that, the guys are going to shine a substitute sun on the very model of a modern miniature landing module. Oh, and a surprisingly talkative toy astronaut.
This is my 1/6 scale model of Neil Armstrong. I can tell it's Neil because he's got the red Commander of the Mission stripes on his suit. What's that, Neil? We really went to the moon. moon. I know. But the thing is that in order to prove that, we got to take some photographs, and to take some accurate photographs, I got to make a ship for you, a home for you. Okay. So these rolls of paper behind me are actually a lunar landing module in Potentia, which I'm about to slap together.
And courtesy of what's known in the editing biz as a few jump cuts, here it is.
Conspiracy theorists are saying that the shot had to have been faked using a fill light. Personally, I think it's because the moon's surface is reflective. And when you think about it, you look at the moon on a clear night, it's obviously reflecting light back at you. That's why you see it. The question here is it enough to create this shot?
To test Jamie's hypothesis that the mythical fill-in light is simply sunlight bouncing back off the moon's surface, the guys black out the set.
Behold our moon landing set. Because it's all about reflectivity, we put blacks all around the shop, covered the whole set to eliminate any spill, any reflected light that's not coming directly from our moon's surface.
That's the landing module, astronaut, lights, and camera sorted.
Dude, this looks so cool.
The only missing component is a moon dust analog that accurately reflects the reflective quality of the real stuff.
The dust that covers the moon is called regolith. When the sunlight shines upon the moon, regolith reflects a certain amount of sunlight back towards Earth. That reflective quality is called its albedo. Now, the albedo of moon dust is between 7 and 10%, according to our sources at NASA.
To make our version of regolith, we used Portland cement and charcoal powder. Now, to measure the albedo, or reflected light coming off of it, we used a light meter and our fake sun.
8%, dude, that is perfect. What we just showed with this test is that our sample regolith has a reflective index of about 8%, which makes it ideal for us to test with. The best part about working with Jamie is that he doesn't need a dust mask. The reason he's not wearing one is because his mustache provides all the particle filtering he needs.
The mock-up moon's ready for its close-up, so it's probably time to up the jeopardy. Cue our resident drama king.
This is the moment of truth. We've got an accurately shaped and textured moon lander, and we've concocted an accurate moon surface that has the same reflectivity index as the actual moon. If the myth is to be believed, our astronaut on the dark side in the shadow of the lander is gonna just fade to total black when we try and take a picture of him. All right, you ready?
I'm set.
All right, here we go. Taking the photo. Let's see. There it is.
Oh, there you go. He's standing full on in the shadow, and you'd think you wouldn't be able to see him. He'd be dark, but he's not. He's in brightest day.
The myth here is that you would not be able to see this astronaut this clearly unless there was a secondary fill light illuminating him. Because he's in the shadow and there's only one light source on the moon, he would by definition be black. Our photo here proves just the opposite. That with a single light source, with the surface of the same reflectivity as the moon, our astronaut is clearly visible, busting that myth.
July 16, 1969, Apollo 11 blasted off from the Kennedy Space Center carrying 3 astronauts on its perilous journey to the moon. 5 days later, as the world watched with bated breath, astronauts Neil Armstrong and Buzz Aldrin became the first men to walk on the moon. But not everyone is convinced that this historic journey actually happened. Over the past 40 years, numerous theories have called into question the photographic evidence that has captivated the world.
And you hear about the fact that the landing was actually done in a television studio.
And there was the big black background with, like, fake stars and stuff. It's the flag being planted on the moon facing one way, and the shadow of the man being the other way.
I've heard that maybe the terrain that was seen on the video wasn't accurate, the walking wasn't accurate.
There are no stars in some of the photographs, and that there should be because there was no atmosphere and that the stars would shine so brightly.
Those photographs can be demonstrated not to have been taken on the lunar surface. Now, if they were not taken on the lunar surface, there's only one other place they could have been taken, and that's on Earth.
On the surface, some of these claims seem reasonable, but do the scientific facts lend credence to these conspiracy theorists?
So with our new technology in Maxwell, we have the ability to do something that's never been done before, which is global illumination in real time. What that means is I can actually simulate the bouncing of light off of multiple surfaces and lighting other objects. With that technology, we looked for what's the opportunity to show this off. And there's this very famous photograph of Buzz Aldrin as he was descending the ladder of the lunar module when they landed on the moon.
We're modeling basically a real-time version of the Apollo 11 landing site in Unreal Engine 4. There's been a lot of speculation over the years about the lighting of that and whether, that the conspiracy theories of whether it was real. And so we thought it'd be cool to try to simulate the lighting of the landing site from an accurate point of view.
We wanted to take on the challenge of showing, no, the single light source of the sun was actually able to light Buzz Aldrin even though he's in the shadows.
The task was a huge undertaking, and no detail was too small to overlook.
It's actually reasonably difficult to get a physically accurate version of the moon because it has a lot of different properties than the Earth.
The environment of the moon and the surfaces of the moon have their own peculiarities. For example, the moon has no atmosphere, so when you see the sun in the sky, you won't see a blue sky around it because there's no air in order to scatter that illumination into the blue colors that you normally see.
To make sure that this is actually accurate, we did a lot of research on the different properties of the lunar soil, the spacesuit material, the material on the lander, looked at a lot of photos, the lunar landing area, satellite imagery of that. We actually had to model the landing site, an astronaut that was realistic to the Apollo 11 spacesuits, model a land that matched the materials and the different colored regions on it and the shape of the lander legs and ladder and all that kind of thing. This all plays into how the image is created.
After the painstaking process of getting every detail modeled in 3D, the team then had to create a physically accurate lunar lighting model.
Well, we have a bunch of different modes that you can adjust in the demo, sort of as a progression through the technology. And the first mode is basically showing it how it would be if there was no indirect light or no bounce light at all. So basically no global illumination. And that mode kind of simulates what it would look like just by default in most game engines. And that's the source of where a lot of the conspiracy theories come from. Because when you look at that scene, Buzz Aldrin is completely in shadow because he's on the shadowed side of the lamp.
The way that we normally think about light is that it comes from a light source, it hits a surface, and then it reflects toward a camera. But actually, light's more complicated than that because it doesn't just bounce straight to a camera, it also bounces and hits other parts of the scene. These interreflections make up a lot of the illumination content.
The next step is basically adding additional point lights to simulate light bounced off of surfaces, and that just has to be placed by a human. And so if we enable that mode, you can see that it doesn't look very realistic at all. The next mode uses Maxwell's new rendering operations to render a more accurate view that actually does take into account spectral reflections, bounce light off the ground.
But even after the light was modeled using NVIDIA's voxel-based global illumination, the image still did not look right.
Part of the challenge was we've got to get the surface reflection of the moon dust, we got to get the reflection off of the lunar module. We got all of that in place and properly modeled, we thought, but the image still didn't look quite right. There was some additional light source that was just missing. Turns out we found a clip of videotape that was shot from the other side of the ladder. As he's coming down the ladder from the opposite side, there is a huge glowing bright white light. And as we analyzed that video a little more, we realized it's Neil Armstrong himself. The bright white space suit that he was wearing reflected all that sunlight off of him and back onto Buzz Aldrin. So essentially, Neil Armstrong himself was a light source in that scene.
It makes sense when you look at the albedo value, which is the amount of light that's reflected into your eye basically from a surface. For the lunar soil is around like 12%, but the suits, because they're like a Teflon coated material, they're around 80 to 90%. And so they're very reflective. It's almost like a mirror, except you can't see something in the reflection, it just reflects the light.
Once we pulled that information in and actually modeled a second astronaut and the light coming off of him, the bounced light was correct. And Buzz Aldrin looked lit properly, as it did in that very famous photo taken in 1969.
Another apparent anomaly in the photographic record is the lack of stars in the black sky. And some say they know why this obvious omission was made.
Astronomers could have easily discerned that the star positions were not those that would have appeared in a photograph taken from the moon. So it's another case where they could not fake it, so they simply ignored it.
The thing to remember is that when they're on the moon, the sun's up there in the sky, and it's effectively daytime for them. Now, if you took a camera and set it up in your own backyard and set the camera settings so that it could get a good picture of everything that's in your backyard, and then kept those same settings waited until the middle of the night and tried to take a picture of the stars, you'd find out that you couldn't see anything.
When you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics.
There actually is a star field in the sky, and we have an adjustable exposure on our camera. So if we crank up that exposure to see the stars, you can see the bright light of the moon's surface starts to glow and get blown out, and they take over the entire scene.
Global illumination techniques have been used by CG artists for over a decade, but has only recently become possible to have this physically based lighting in real-time graphics.
For the longest time, global illumination has been used in film and offline rendering to get the nice, subtle look of lighting bouncing off of multiple surfaces. Unfortunately, it's just been too hard to do in real time. Now with Maxwell, however, we have enough horsepower to do global illumination in real time, so we can get that same kind of subtle lighting effect in games and all these real-time applications because of the power of Maxwell.
Maxwell makes this possible because in order to do the global illumination, we have to produce a voxelized version of the scene. And Maxwell is actually very efficient at doing multiplanar rendering, which is required to do this. It also can push a whole lot of polygons because, computing different levels of detail of the voxelized data requires multiple passes over the scene. And so being able to atomically access memory much more efficiently, that allows you to compute this thing much faster than was feasible before. When you compare the photo with the final rendering, they're actually strikingly similar. So I think lends credence to the fact that it's not a conspiracy.
So the lunar landing demo is a very nice recreation, not just of the 3D geometry of everything that was in the scene at this landing site, but a lot of attention to detail as to how the materials would have reflected illumination and where the light was coming from, and simulating that light hitting these materials. And that combination of attention to detail is why this thing can be regarded as a pretty good pass at what it would have really looked like up there on the moon.
It's tough to prove a negative, right? Can I prove that they didn't shoot this thing on some Hollywood soundstage? Nope, I can't prove that. But what I can prove is that the lighting environment on the moon can indeed be modeled and run in real time on Maxwell, such that we can see that with that single light source of the sun and the bouncing of the light off the surface of the moon, we can see Buzz Aldrin while he's in shadow. So now in 2014, yes, I could go around and in real time, I could make a game of walking around on the moon, and it would look as real as it did in any of the photos that you saw from the moon landing. I could do that in 2014 technology. In 1969 technology, no way.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
It was a giant leap with the best of 1960s technology. Much has been made of the fact that today's gadgets are well in advance of those used to put a man on the moon. But almost 40 years after NASA's last lunar excursion, is this the gadget to end moon landing conspiracy theories? The Lunar Reconnaissance Orbiter Camera, or LROC, has spent the last month taking high-definition images from around 13 miles above the moon's surface. The results, the best images yet of visits to the moon.
It's one small step for man, one giant leap for mankind.
Apollo 11 carried Neil Armstrong to fame, but LROC has focused elsewhere. NASA's return trip to the moon in Apollo 12 was spotted, as well as the third lunar landing on Apollo 14. The most recent and final visit, Apollo 17, leaving the most evidence with experiments and lunar rover tire tracks. LROC's glance at history is not its primary mission, the camera collecting data to pave the way for possible future missions. But has it finally closed the book on moon landing conspiracy theories? That might be a leap too far.
Here they are landing, and you can see the pudding effect of the soil. And now you see those strange, what I call special effects light rays. If that were really sand, it would be covering up all of that, which is beneath it, but it doesn't fill in holes, doesn't cover mounds. And it looks like light rays photographed underwater, not dust being shot away at a 10,000-pound thrust rocket engine. And you can see here, nothing gets covered up, nothing changes when it lands. There it is.
The original plan had called for Young and Duke to get out and explore shortly after landing. However, the near abort had lasted 6 hours. The tired astronauts would sleep. Their first traverse would take them about 1 kilometer west of the landing site. They would make 2 stops to collect samples and conduct experiments.
Now this is the most interesting thing, Frank. There's the rover on the top of the hill. Notice the rock in the center. It looks like an alligator with its mouth open. And look at all the other rocks. You're going to see them again.
John, you're just beautiful. That is the most beautiful sight.
Note the rover on the top of the hill.
Today they were headed a little over 4 kilometers south to climb their rover up the side of Stone Mountain.
Man, we're really going up a hill, I'll tell you.
Their first station, a crater 700 feet above their lunar module.
And there it is again, Frank. The same mountain, the same alligator rock, different time, different day, no rover in the background. This has to be your biggest embarrassment. This was a stage set somewhere in America.
Isn't it, John? It's absolutely unreal.
They should have caught this, but they didn't. If there's ever proof that you faked all of this, this frame alone would do it. Shot somewhere in the American desert. It's all showbiz, Frank. This appears to be high noon on the moon, 250 degrees in the sun. They should have cooked and baked inside that LEM. And Eastman Kodak told me that film melts at 150 degrees. None of the film taken on the moon at this type of temperature should have survived. It should have been crisp like in an oven and curled and melted.
171 hours and 37 minutes.
The lunar surface is one of the most recognizable in history. But why are such important images so grainy and hard to see?
And we're getting a picture on the TV. You had a good picture, huh?
NASA claims it's the result of 1960s technology.
NASA orchestrated the hoax in a very unique way through television. One picture, which they completely controlled, black and white, grainy, that convinced everybody we were on the moon. We had no reason to doubt it. They had complete reins over the pictures, over the sound. I mean, sad to say, it was easier than people believe.
The evidence suggesting that these images were staged.
It's absolutely unreal.
Although it appears that the astronauts are moving in the moon's gravity, which is 1/6 that of the Earth, Percy notes that when the speed of the film is doubled, the astronauts appear to be running as if in Earth's gravity. Also, when the footage of the lunar rover is doubled in speed, it looks as if it's driving here on Earth. If there is no air or wind on the moon, why is this American flag waving?
The fact that the flag flaps on the moon where there's no atmosphere means that there must have been a little blast of wind out in Area 51 where they shot this.
Could these questionable images simply be the result of astronauts struggling to plant the flag into the lunar surface? Or is there more going on than meets the eye? What about the still photography? Some say the design of the bulky spacesuits would have made it extremely difficult for the astronauts to operate their chest-mounted cameras. The man who designed these cameras is Jan Lundberg.
Once on the moon, on the lunar surface, in the dress, in the life support system, you couldn't see the camera. They couldn't bend their head that far down. They had no viewfinder, they had to aim by moving their body.
If the cameras were so difficult to manipulate, how were thousands of photos taken with crystal clarity and precise framing?
The pictures that we see that allegedly were taken on the moon are absolutely perfect.
But with closer examination, Casing says flaws begin to emerge.
Unfortunately, errors were made which are now being discovered.
Point out that lighting is a major flaw in the lunar photos. Case in point, on the moon, the astronauts' only source of light was the sun.
They had no extra lighting, no flashes, no things like that.
Yet in this photograph from Apollo 14, the shadows are cast in different directions, suggesting multiple light sources.
The shadows cast by the rocks in the foreground should have been east-west, like the LEM shadows.
And in this photo from Apollo 17, again the shadows are pointing in different directions.
Outside in sunlight, shadows always run parallel with one another, so the shadows will never intersect.
It's not just the shadows that indicate the use of additional lights, but what has been photographed in the shadows. For example, here's an astronaut who descends into a huge shadow cast by the lunar module. Yet his entire body is still visible. How is it that he is not shrouded in darkness? Here's the same maneuver from another Apollo mission. Again, the astronaut is brightly lit in what is obviously dark shadow. And in this picture, the sun is directly behind the astronaut. His figure should be a silhouette. Yet even the smallest characteristics of his suit are recognizable.
It seems like he's standing in the spotlight. And I can't explain that. That escapes me. Why?
And finally, in this picture with the sun behind the lunar module, the front of the craft is clearly visible. The words United States are crisp and clear. How could these backlit pictures be so detailed?
It's because there's more than one light source, which means they're not on the moon.
But NASA simply dismisses these arguments. But the questions continue. Why do some of these images shot at different times and different places appear to have identical backgrounds? These two photos seem to have the same mountain backdrop, yet the lunar module is only present in one of them. Seemingly impossible, since the LEM never moved and its base remained even after the mission.
What a ride, what a ride.
Some suggest the same artificial backdrop was used when shooting two entirely separate pictures. Background discrepancies are also apparent in the lunar video.
The best evidence are some pictorial anomalies in the photographic record of the trip to the moon. There is one for Apollo 16 where the same shot, the same hill, appears in 2 different days.
This tape was shot on what was reported to be the first of Apollo 16's lunar excursions.
But it couldn't pick a better spot.
And this video was from the next day at a different location.
That is the most beautiful sight.
NASA claims the second location was 2.5 miles away. But when one video is superimposed over the other, the locations appear identical.
It's absolutely unreal.
Even closer examination of the photos suggests evidence of doctoring. For reference, crosshairs were permanently etched into the lunar cameras, so they would have to appear on top of every image. But in this photo, a crosshair is behind a part of the lunar rover.
This situation is impossible and has to be the result of technical manipulation and doctoring of the image.
And in this photo from Apollo 11, the equipment in the foreground is covering the crosshair, not behind it. And in another from Apollo 12, the American flag is covering one crosshair, and the astronaut is covering the other. When presented with these questionable photos and videos, Apollo was a hoax.
Oh, you're early. I didn't hear you come in. I was just learning about the wonderful things on the internet. You see, in the 1960s, we didn't have the internet. You know what else we didn't have in the 1960s, besides private HD chat rooms? Conspiracies! We just believed the horse shit the government fed us, and we chased it down with a shot of cheap brandy. Yeah. Did legendary filmmaker Stanley Kubrick, who directed such masterpieces as The Shining, Full Metal Jacket, and Dr. Strangelove, help perpetrate an Apollo 11 moon landing hoax for NASA?
I was strolling on the moon one day in the merry, merry month of December. May, that's right.
Now, I have been watching a lot of conspiracy videos on the subject, and there is some interesting footage and information out there about similarities between the back projection used in 2001: A Space Odyssey and actual shots from the moon landing. Also, NASA did have models and mock-ups of the moon for training purposes.
Rumsfeld offered to go and negotiate personally with Stanley Kubrick. He and Henry Kissinger flew to England that same evening. Kubrick was surprised and amused by the idea, but began by refusing. Rumsfeld wouldn't give up. "We're only asking you to do one thing. Just leave us the keys to the studio for one weekend, just so we can shoot a bit of film and take a few shots. Everything will be tidied up again by Monday morning." Kissinger flattered him, telling him that Dr. Strangelove was one of Nixon's favorite films. In the end, Kubrick agreed. The fake footage would be shot in England in the MGM studios near Boreham Wood with a skeleton crew. The 2 technicians and 2 actors would be CIA agents.
Now, whether you believe in the conspiracy or not, there are some interesting parts of The Shining that I believe to be messages from Kubrick himself about his involvement. For instance, take a look at that shot of the kid playing with the fire trucks around what I believe to be a tiny NASA launch pad. Also, look at his sweater. It says Apollo 11. Interesting. Now, the boy Danny, he gets up and goes down the hallway to room 237, but in the book, it's room 217. What's the significance of 237, you ask? Well, the moon is 237,000 miles from Earth. You see, I believe that Danny represents the Apollo 11 mission to the moon. And him going into room 237 is the same as Kubrick going into the studio to film the moon landing.
But Stanley Kubrick was a perfectionist. Faced with the CIA crew's lack of professionalism, he ended up, against his better judgment, supervising the shooting of the fake moonwalk. "But," he told them, "from Monday morning, you're out of my life for good."
Now, when the kid comes out of the room, his Apollo 11 sweater's torn, and he has marks on his throat, and he can't speak. A metaphor for Kubrick being silenced about his involvement in the whole thing. There's also little hints sprinkled into the storeroom. There's a box that reads Box 39. Now, what was the launch pad number for the Apollo 11 mission? What was it? Let me think. 39! Also, there's Tang in there. Tang was the drink that the astronauts used to drink on space flights.
Ice cold glass of Tang. Tang is for Earthmen who just don't want to be earthbound. Drink Tang and go. Tang, the energy breakfast drink for Earthmen.
Would Richard Milhous Nixon lie to us? Would America lie to its people just to beat the Soviet Union in a race to the moon?
Neil, you are dark on the rock.
Mission is a go. We have 21 minutes.
Everything was so much easier in the 1960s. They were fantastic. Politicians were honest. Cigarettes were good for you. Who needs a filter? Only pansies wore seatbelts. Martinis at lunch? Drinking and driving, no big deal. In 1984, it was just a book, not a how-to manual for the NSA. What? That's un-American. What are you, some sort of commie bastard? Some kookamamie conspiracy theorist? Ugh. These things will kill you. What do you guys think? Did the Apollo 11 really go to the moon? Was Kubrick even involved? Or maybe was he just a backup plan in case things went wrong? Let me know what you think in the comments below, in code.
Hey, how's it going, you guys? Okay, this is so debated. Did the moon landing happen? Well, you know what? We're about to learn a whole bunch of things in this video, and at the end of it, you guys tell me, was the moon landing a hoax? Let me know in the comment section below. So how's it going, all you most amazing top 10ers? I'm so glad you guys came back. I'm Landon. This is a channel where we take interesting and unusual things from around the world and sometimes outside of the world and compile them into a top 10 list for your enjoyment. So today I'm going to be talking about the top 10 moon landing hoax theories. Moon landing conspiracy theories claim that some or all aspects of the Apollo mission and the associated moon landings were a hoax staged by NASA. And this is with the help of other organizations, and this was an attempt by the US government to assert their victory in the space race over the Soviet Union. A poll has indicated that approximately 20% of Americans, maybe some of you guys, believe that the US has never landed on the moon. So what do you guys believe? Maybe this video will change your mind. So let's get started. In our number 10 spot, this theory is a little far-fetched in my personal opinion, but some theorists believe that the footage was filmed in a studio and the editors reduced the speed to slow motion in order to mimic the low gravity conditions. It has been suggested that if you increase the speed of the footage by about 2.5 times, the astronauts appear to be moving in Earth's gravity. They also believe to account for the astronauts jumping high, hidden cables and wires were used. Number 9 takes us to the discrepancies with their shadows. On the moon, the sun is the only strong light source, meaning all of the shadows should be parallel with one another. However, this is not the case, because seen in all the videos and photographs, the shadows fall in different directions. This made many people believe that there must have been multiple light sources, which suggests that the landing photographs were taken on a film set. NASA argued that the uneven landscape was the culprit for the strange shadows. So in at number 8, we have the small impact crater. This conspiracy theory suggests that if they really landed on the moon, there would be a sizable blast crater underneath the lunar module after landing on it. On all of the footage or photographs of the landing, there wasn't a visible crater. The surface of the moon is covered in fine lunar dust, but even this doesn't seem to have been displaced while landing. NASA combats this theory by stating that the module required significantly less thrust due to the low gravity conditions that it would have done on Earth. So everything just seems to have some sort of explanation. In at lucky number 7, we have the mysterious object. When the photographs of the moon landing was released to the public, theorists noticed a mysterious object in the reflection of an astronaut's helmet from the Apollo 12 mission. They claimed that this object appeared to be hanging from a rope or wire, which led to some to suggest that this is an overhead spotlight that can typically be found, of course, in studios. To this day, this object still remains unexplained, but due to poor quality of the photograph, maybe this was done on purpose, I don't think we're ever gonna know what this object really was. Up next, in at number 6, let's talk about Van Allen radiation belt. The astronauts en route to the moon had a trajectory that would pass through the Van Allen radiation belt. The belt is held into place by the Earth's magnetic field, and it is known to stay in the same place. The Apollo missions to the moon were the first ever attempted to transport humans through this belt. Many people believe that the levels of radiation emitted from this belt should have cooked the astronauts when they attempted to pass by this belt, despite the many layers of aluminum coating they had on. However, NASA argued that the astronauts were only exposed to this radiation for a short amount of time, so they only received a very small dose of it. Blowing its way into number 5 is the waving flag theory. Some conspiracy theorists have pointed out that when the first moon landing was broadcasted on live television, the viewers could clearly see the American flag waving as Neil Armstrong and Buzz Aldrin planted it into the ground. So the problem with this is that there's no air on the moon's atmosphere, which means there is no wind that could cause the flag to blow. NASA claimed the flag was stored in a thin tube and the rippled effect was caused by it being unfolded before being planted. Others claim that the rippling of the flag was caused by the astronauts touching and shaking the pole. Number 4 takes us to the C rock. One of the most famous pictures from the moon landing was a rock with the letter C engraved into it. The letter C appears to be almost perfectly symmetrical, which means that it is highly unlikely to be a natural phenomenon. So this makes many people believe that this rock is actually a prop that was used. They suggest that a production crew member could have turned the rock the wrong way accidentally, which exposed this letter to the camera, because Apollo was the first ones there, so how could have someone been there before and put the letter C on this rock? NASA countered this argument by saying that it could have been a strap here that got tangled up somewhere in the development process. They also went on to blame a photographic developer for adding the letter C as a practical joke. Landing its way into number 3 is the identical backdrop. Take a look at these two photos from the Apollo 15 mission. They clearly have identical backdrop despite NASA claiming that these photos were taken miles apart. One of the photos even showed the lunar module, so when all of the pictures were taken, the module had already landed. So how could there have been one picture and then disappear in another? Some hardcore conspiracy theorists believe that NASA used the same backdrop while filming different scenes for their moon landing videos. NASA came back with their response that since the moon is a lot smaller than Earth, horizons can appear significantly similar to the human eye. Okay, so we're almost at the top of this list, but first, coming into number 2 spot, we have the crosshairs. The astronauts had cameras with crosshairs to help them with scaling and direction. These crosshairs are imprinted over the top of all photos. Some of the images, however, clearly show the crosshairs behind objects in the scene, which implies that the photographs might have been edited. Many objects are seen to be in front of the crosshairs, including the American flag that was seen in one of the pictures and the lunar rover in another picture. Okay, so making its way into number 1 for the top 10 moon landing hoax theories is the lack of stars. One of the most compelling arguments for why the moon landing was a hoax is the lack of stars in any photographs or videos. Since there are no clouds on the moon, stars should be exceptionally visible and significantly brighter than what we see here on Earth, because a lot of times I don't see it because of light pollution. Many of these conspiracy theorists believe that NASA could have found it impossible to map out the exact location for all these stars, so NASA intentionally left them out with the excuse that the quality of the photographs washed out the visibility of the stars. So I'm starting to think this, one of two things. NASA is really good at producing videos and like they are good at Photoshop. NASA isn't scientists, they're actually filmmakers. I don't know if you believe that. Or maybe the moon landing was actually real. Let me know your guys' comments in the comment section below. Hashtag moon landing real, hashtag moon landing hoax. That's it for me in this video, guys. I'll see you in the next one.
And I want to show you that even today, there is evidence that lines up with what the Bible teaches about the age of the universe. Scripture teaches a young universe. It's clear that God created in 6 days, and it tells us what he did on each of those days. It's clear from context. Those are ordinary days because they're bound by an evening and a morning. Some people have tried to stretch that out into ages, but that won't work in the Hebrew based on the context because you're bound by evening and morning, and there's a number with them and so on. Human beings are made on the 6th day. And from those genealogies you love to read before you go to bed, and so beget so-and-so, you can add up those ages, and it's no harder than balancing your checkbook, and it's a few thousand years. And the universe, by the way, that most of the celestial objects in the universe are made on day 4, and so that pins the universe at a few thousand years as well. That goes against what I was taught. I went through the secular school system, and I was taught billions of years, but there's evidence that confirms thousands of years. For example, the excess internal heat of the giant planets. Jupiter gives off twice as much energy as it receives from the sun. Okay, it's actually, it gets some energy from the sun, but it gives away twice as much. Okay, and you can't keep doing that forever, right? Because it's losing energy. You can't continue to spend away, more than you take in, unless you're the federal government, right? Well, Jupiter's losing energy. And it can't do that forever. The federal government can't do that forever either, by the way. Anyway, it's kind of like when you take a potato out of the microwave. It's nice and warm, and it radiates that heat out into space, right? But it can't do that forever because it's only got so much energy. It cools off. And for a potato, it doesn't take that long. Now, Jupiter is a much bigger potato. It's 10 Earths across. And so a few thousand years, it's not going to cool off very much. But if it were billions of years old, why isn't it an icicle by now? That's a problem for the secular view. The problem's even worse for Neptune, which gives off 2.7 times as much heat as it receives from the sun. Why is it so relatively warm if it's really billions of years old? And that's a perplexing dilemma for the secularists, but it makes sense given that they're young. These worlds are thousands of years old. The Earth's magnetic field. The Earth has a magnetic field that's caused by electrical current in the core, and that makes that magnetic field that surrounds us like a blanket, protects us from solar radiation and cosmic radiation and so on. And of course, you can make a magnet by taking a coil of wire and wrapping around, touching it to a battery. That's electrical current causes magnetism. And just like a battery runs down, Earth's magnetic field is running down. Earth's magnetic field is actually decaying. And we've been able to measure that over the centuries. And it's been decaying in a steady exponential decay. Now we think during the flood year, because of all the tectonic activity, that would have disrupted those currents, and you'd have rapid oscillations in the field strength. But the total energy is just going to drop. So in terms of the total energy, it's just been dropping since creation. And we can measure that. We know from the last almost 2 centuries, we can measure the drop in the magnetic field. It's quite consistent with that exponential decay. It's exactly what we'd expect, which means you run it backwards, and at creation, it was a bit stronger than it is today. But you run it back 1 million years, and it gets so strong, it rips the iron out of your blood, and that's not good. It would actually make life impossible if the magnetic field is as strong as would be required if it was even millions of years old, let alone billions. And so it's a big problem. My secular colleagues have to believe that it doesn't have this exponential decay, but that it's constantly oscillating back and forth, but there really isn't evidence for that today. Again, there might have been temporary oscillations during the flood year, but that just drains the energy even faster. It's not just Earth, but a lot of the other planets of the solar system also have these magnetic fields. Jupiter's would be bigger than the sun if you could see it. It's a very powerful magnetic field. And why is it still so strong if the planet's billions of years old? And I'm going to suggest it's because the planet's not billions of years old. It's thousands of years old. So it hasn't had time to decay yet. The planet Uranus. Uranus is tilted on its side as it orbits the sun, so it rolls around the sun. It's one way to think about it. And the magnetic field axis is stuck in the side like a bar magnet. It's not even lined up with the rotation axis, so the magnetic field would wobble as the planet rotates. Really strange. So the planet Uranus is just really messed up on a number of levels. And I think God did that just out of his creative diversity. But the magnetic field, I want to point out, the magnetic field is quite strong on the planet Uranus. In fact, it's strong enough you can have aurora borealis, northern lights. We have northern lights from time to time when Earth's magnetic field gets disrupted by solar radiation. And that's because of Earth's magnetic field. Well, that's northern lights. That little spot you see there on the bottom, that's not photoshopped. That's an actual image of northern lights on the planet Uranus. How about that? And it's much further away from the sun than we are. So that shows you the magnetic field has to be pretty substantial. And in fact, the Voyager 2 spacecraft, when it flew past the planets Uranus and Neptune, it measured their magnetic field and confirmed that it's consistent with thousands of years of decay. Isn't that interesting? My colleague, Dr. Russ Humphreys, who used to work for us at ICR, he's retired now, but he actually predicted the magnetic fields of Uranus and Neptune before they were measured by the Voyager 2 spacecraft. And he based that on their age of 6,000 years. He said, okay, based on 6,000 years of decay, here's what the magnetic field should be. The evolutionists thought that those planets are billions of years old, and so they thought the magnetic field should be virtually non-existent. Voyager 2 measured it. It was perfectly consistent with creation. How about that? Consistent with 6,000 years. That's real science right there. If you want to get the correct answer, you better start with the truth of God's Word, rather than ignoring that history and relying on guesswork instead. My secular colleagues, perplexed by that, have said, well, there must be some kind of recharging mechanism that builds up the magnetic fields again. And if you've heard of magnetic dynamos, that's what magnetic dynamo models are. And they have problems of their own. One of them is that in the magnetic dynamo model, the rotation axis should be aligned with the magnetic axis. Is it? Not even close. Not even close. And they said, well, maybe that's just an anomaly. But when they flew past Neptune and it was doing the same thing, that kind of blew away that hypothesis. No, it's just consistent with thousands of years. The moon is actually moving away from the Earth. It's actually, and the reason it does that, the moon induces tidal bulges on the Earth. It pulls on the Earth's oceans, and that causes these tidal bulges. The tidal bulges get ahead of the moon because the Earth rotates faster than the moon orbits, and so the tidal bulges are always a little bit ahead of the moon, and they pull forward on it. And the counterintuitive thing is when you pull forward on something in orbit, it moves out. When the astronauts want to go into a higher orbit, they thrust forward, and that moves them out. It's a little bit strange, but if you've ever played with a gyroscope, you know that when things are spinning, they don't always act the way that your intuition would expect. But the moon is moving away at about 1.5 inches a year, so it's not a huge rate. If you run it backwards, that means 6,000 years ago, it would have been something like 730 feet closer to Earth. Not a big deal, considering the moon is 248,000 miles away. What's 730 feet among friends, right? But if you run it back billions of years, you got a problem. And you have to do the math right on this, by the way, because if you're running the movie backwards, as the moon gets closer, the tidal bulges get bigger, and it gets closer, and they get bigger, and it gets faster, you see. And it dives in at 1.4 to 1.5 billion years. So the Earth and moon would have been in the same place at the same time, and that's not good. And that happens at 1.4 billion years. And that may sound like a lot, but my secular colleagues believe the Earth and moon to be 4.5 billion years old. But they can't be older than 1.4 or 1.5 based on the recession rate. So it's just an indication that their worldview isn't correct. It doesn't make sense of the evidence. Comets are made up of icy material, and they orbit the sun in elliptical paths. They tend to go very far away from the sun, and then they come close and they whiplash back out. And when they're far away from the sun, their icy material remains icy material. When they come close to the sun, ice close to the sun, that can't be good. That icy material is blasted away from the nucleus of the comet. It's vaporized. And that's actually what forms a comet's tail. That's dust and other material and ice being blasted away by solar heat and radiation. So every time you see a comet, it's getting smaller. And by the way, that's why the tail always points away from the sun, regardless of what direction the comet's moving. I don't know which way this one's going. It might be going that way. Who knows? But the tail always points away from the sun for that reason. Every time you see a comet, it's getting smaller. It's losing mass. And it can't do that forever because it has no source of new mass. So it just gets evaporated away. And we estimate that a typical comet can last no longer than 100,000 years maximum. And some of them much less than that. I used the SOHO spacecraft in my doctoral dissertation, and one of the things it can do is it's designed to look at the sun, and one of the things it can do is it can block the actual sun and look at the outer atmosphere of the sun, the corona, and because of that, it's very good at spotting comets, because comets get really bright when they get close to the sun, hard for us to see them because of the solar glare, but SOHO is designed for that. And so SOHO has discovered over 1,000 comets, and I've seen them because I've used the spacecraft in my research, and I've seen comets that have gone behind the sun, and that's it. They're totally obliterated in one pass. They don't even survive. Interesting. So I know that they're short-lived. They can't last millions of years, let alone billions of years. Now, my secular colleagues believe the solar system's 4.5 billion years old. So why do we still have comets? It's kind of like if you walked into a sauna, nice and warm, and you see some ice cream cones there just starting to melt. You know they haven't been there very long, right? Comets are sort of the ice cream cones of the solar system. They are an indication of its youth. And by the way, my secular colleagues, they know that. They can do the same math I can do. They can calculate the rate at which the material is leaving, and we know the amount of material that's there in the nucleus. They know that comets can't last long. And so they figure there must be somewhere out there a comet generator that makes new ones, which they call the Oort cloud. If you've ever heard of the Oort cloud, that is an invented idea to try and explain why we still have comets in a solar system that's supposedly billions of years old. And the idea is there's this vast reservoir of potential comets out there orbiting way beyond where we can detect them. And every now and then one of them is thrown into the inner solar system, becomes a brand new comet. Pretty clever. There's no evidence of an Oort cloud, though. The only place you'll find it is in textbooks, but you won't find it in the actual universe. Not yet, anyway. My secular colleagues have a lot of faith in these kinds of things. Spiral galaxies. Now, not all galaxies are spiral. Some have more of an elliptical shape, but a lot of them are spiral. And these spiral arms rotate differentially, which means the inner portions rotate fast, as indicated by the arrows. The outer portions rotate slower. And so what you would think then is the galaxy would have to be twisting itself up. It's winding itself up tighter and tighter. That spiral structure would have to get tighter every rotation. And it turns out in 6,000 years, it hasn't rotated even once, and so it's not a problem. You can, in fact, in these barred spiral galaxies, you can still have that bar structure there. It's just starting to wrap up a little bit in the middle there. In 6,000 years, not a problem. But if these galaxies are billions of years old, it'd be a huge problem because they'd be twisted beyond recognition. I recently wrote a computer simulation to use the actual velocities that we've measured in these galaxies to simulate what they would look like in 1 billion years. They're totally unrecognizable. You would not see that spiral structure. They look more like a, I'll have to show a picture of it at some point. I'll show you the results of the simulation, but it's really interesting. They wouldn't look anything like this. This looks like a young galaxy, and the interesting thing is all the spiral galaxies look kind of like that one. They have very distinct spiral arms. They don't have that real tight spiral structure that you would expect if they were really 10 billion years old. In fact, even after 1 billion years, you can't have spiral arms anymore. And they're supposed to be 10 billion years old? It doesn't work. And so my secular colleagues have to figure out ways to make new spiral arms as the old ones are wrapped up beyond recognition, spiral density waves and whatnot. But it's just easier to believe that the galaxies are the age the Bible indicates. That makes sense of their structure. You might notice, too, that these spiral arms have kind of a bluish tinge to them. That's because they have a higher proportion of blue stars relative to the central bulge. And blue stars themselves are an evidence of the youth of the universe, because blue stars cannot last very long. They expend their fuel quickly. Blue stars are the most massive, most luminous, the brightest stars out there. And because they're giving out their energy so quickly, they're spending it like crazy. They can't last very long. They run out of fuel very, very fast. Now, they have the most fuel, right, because they have the most mass, but they expend it even quicker. They're kind of like the SUV of the star world. They have a big tank, but they get very poor gas mileage, and so they can't go very far. They can't last very long. The hottest, brightest blue stars can't last more than about 1 million years, and yet we find blue stars all over the universe. All over the universe. They're there. And my secular colleagues have to believe that, well, they obviously have formed there recently, but no one's ever seen a star form anywhere. Oh, you'll read about it in the newspaper. You know, they'll call this a star-forming region. Well, let me clue you in. What they're doing, they're not seeing stars form there. What they're finding there are blue stars that they know can't be billions of years old. And because they can't accept a recent creation, they have to say, well, apparently stars have formed there very recently, and so it must be a star-forming region. But nobody's actually seen a star form. And I think there are some very serious physics problems getting a star to form from a nebula. The idea is these nebulas collapse in on themselves, but gas normally doesn't collapse in on itself. Gas normally fills the container, right? When you walked into this room, you didn't hold your breath just in case all the air should go to that corner. You expected it to spread out. And aren't you glad that it did? Gas tends to do that. Gas pressure tends to be a lot more substantial in space than gravity. Now, once you make a star, its own gravity will keep it there because the gravity overcomes the gas pressure. But getting it to that state is a challenge, and it may even be impossible. So these are all just indications that the universe really is the age that the Bible says. And there are a lot more, but those are the ones that I think are some of the better arguments for which the secularists don't really have a good counter-argument.
We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space.
On July 20th, 1969, 3 astronauts flew 3 days to the moon. When they got there, 2 astronauts, Neil Armstrong, Buzz Aldrin, got into the lunar excursion module called a LEM and made their way down to the moon. The journey took another 2.5 hours. It was apparently a lot harder than they expected. With only 40 seconds worth of fuel, Neil lands the LEM on the surface of the moon. Michael Collins orbiting the moon. waiting for their return. Shortly after they landed, Armstrong left the LEM and makes the first step on the moon. That step, one small step for man, one giant step for mankind. Shortly after, Buzz Aldrin makes his way out of the LEM and very carefully, without locking the door, the hatch, because as it turned out, they never designed a door handle on the outside, makes his way out of the LEM and down the stairs. What you're looking at here is that seminal photograph that was taken by Neil Armstrong. A seminal photograph taken by Neil Armstrong of Buzz Aldrin as they landed on the moon, as they stepped onto the lunar surface of Tranquility Base. Tranquility Base. Well, those photographs came back to Earth, and of course, to this day, still takes my breath away thinking about it. It was a step for man, but surely a giant step for mankind. But those photographs came back, inspired hundreds of millions, but at the same time, caused many people to be quite excited about whether the origin of this photograph was truly from the moon. There was good reason for them to question these photographs. First of all, when you look at that image of Buzz Aldrin, and you look at the shadows on the ground, the dark shadows, he's surely in shadow. If he's surely in shadow, because the sun is on the other side of the LEM, how is it possible that he is that bright? Second, we know there's no atmosphere on the moon. And if there's no atmosphere on the moon, we should be able to see the stars. Clearly, they knew that we could very easily, through the positioning of the stars, determine whether they were actually on the moon. And the belief is that it must have been too complicated to line those up, so they decided to leave them out. It is possible that this photograph was taken here on Earth. Now, with the invention of VXGI, and through the extraordinary efforts of our engineers, we meticulously model the lunar LEM. Here's the wonderful thing about the lunar LEM. It's made out of aluminum foil, cloth, and a generous application of tape. It was a flying Coke can. No wonder Aldrin and Armstrong wanted to get out of that thing as fast as they could. It was a flying Coke can. We modeled every detail. We had to model every single detail. We modeled the surface of the moon so that we could start to study and test these mysteries and come to our own conclusion through scientific means whether it is possible, whether they did land on the moon. Ladies and gentlemen, I'd like to demonstrate to you guys now our work. Every single little detail. Now, first of all, Come on, fess up. You thought that was a photograph, right? That was a photograph. You thought that was a photograph. The first time I saw it, it was rough. But by the time I saw the final works, I thought it was a photograph. It's really, really amazing work. The engineers modeled every little detail. And so let's go through and let's test each one of those conspiracy theories. The first one is this. Curtis, let's go to, let's assume that he is in shadow and that the only light source is direct. Well, this is what it would look like. This is what Buzz would, and this is what people expected him to look like. And the reason for that is because the sun is on the other side of the lamp. And you can also see the shadows on the ground are perfectly dark. So how is it possible that he's lit? Well, as it turns out, we modeled the entire surface of the moon. We modeled the dust particles of the moon, and we learned this. We learned that the dust particles on the moon, which is created obviously from asteroids bombarding the moon, okay, relentless over billions of years, it's fine particles, and it in fact has reflective properties. Now, the reflective properties are not great. It only reflects about 10, 12% of the light that hits it. However, as in many type of dust particles and crystals, when a light hits it directly and you look at it from the same angle as the light source, the reflected light is multiple times brighter than it otherwise would have reflected. It's a phenomenon called opposition surge. Well, we simulated the properties of the moon dust, and as you can see, right now, the sun is behind me, the lamp is beside me. Notice the brightness of the sun as it's reflecting off the lunar surface. Well, suppose we were to turn on VXGI, and we turn every single surface into a light source so that it reflects the light. Let's see what happens. Well, voila. Reflecting off of this lunar surface, the sun was able to light Buzz Aldrin. Well, that's mystery number one. Mystery number two is this. Why is it that while we're looking at him right now, we don't see the stars? Well, that's a simple answer. Turns out it's a simple matter of exposure. The light is so bright, in fact, that they had to change the exposure of their camera to the point where you're not over blindingly bright on the surface of the moon, while therefore you're no longer able to see the stars. And so what we did was this. In fact, when we look out into the sky, we've modeled all 84,000 of the closest stars around Earth that we can see from Earth. And if we were to change our exposure, this is what we would see. Now, Curtis, what would happen now if we were to look back down? Now, this is what they would have seen if they were to adjust their pupil and got accustomed to seeing the stars and then look back down. Everything would be so white, so bright, because of the sun's brightness reflecting off the surface of the moon. Now let's change the exposure again, please. Look how beautiful that is, huh? Hey guys, what do you think? Real-time computer graphics with real-time global illumination. Well, there's another conspiracy. This particular question was kind of interesting. Well, it turns out, can we go to the slide, please? When you look at this other iconic image of Buzz stepping on the moon, it's taken from a camera that plops down from the limb, and it captured Neil Armstrong coming off the ladder, and it captured Buzz Aldrin coming off the ladder. The theory that this photograph was in fact taken on Earth was because some believed that light source, that really bright light source beyond Buzz, was in fact a light that they forgot or somehow mistakenly did not take out of the way when they took this picture. And so if we were to go back to our simulation, in fact, if you were to look at that, well, shucks, that's an interesting question. That's an interesting question. Until, if you were to figure out where Neil Armstrong was standing when he took the other iconic photograph, you'll discover that, lo and behold, there's a white object there. Well, here's the amazing thing. Neil Armstrong's spacesuit is made out of largely Teflon, a material called beta cloth, and it has a reflectivity of about 90%. All the light that hits Neil Armstrong, 90% of it bounces off. Now you could just imagine how bright the sun is. Without being disrupted by the atmosphere, it lights up Neil Armstrong, and it helped us solve one last unexplained issue when we were working on this project. The one last thing we could never figure out is why is it that when we compared, and now we've simulated everything to death. We simulate the brightness of the sun, we simulate the reflectivity and the material of the lunar surface. We've captured all of the geometry. We've put all the right materials into the lunar lander, and the lunar lander is reflecting off and also projecting its light on Buzz. We've modeled every little detail. Now, why is it that when we look at it, Buzz still seemed too dark? Well, it wasn't until we modeled Neil Armstrong and we put him in the scene that we were able to see the difference. How about let's turn Neil on and off. Off, on. Off, on. That little tiny detail, and we'll show you in just a second, is so compelling that we now understand why it is that Buzz was lit the way he was. Well, let's take a look at, let's step out and take a look at Neil and what he looks like. There's Neil.
Yeah.
Isn't that beautiful? The extraordinary detail that the engineers put into it is just really, really wonderful to see. And then lastly, let's compare the before and after. If you can go to slides. If you're not sure, the right side is the photograph. The left side is the simulation. What do you guys think? In the example of the Cornell box, I used essentially a photograph to test real-time computer graphics. And we continue to improve its capabilities. We added VXGI, and as a result of that, real-time computer graphics came awfully close to the image that was generated by iRay. Now that we have VXGI, we use the technology, the engineers use the technology to test against a controversial, iconic, seminal photograph that was taken in the 60s.
4 decades have passed since Neil Armstrong took that giant leap for mankind. On July 16, 1969, America's Space Administration, NASA, fulfilled Kennedy's pledge that the United States would be the first nation to put a man on the moon by 1970. It was a definitive space race victory against Soviet Russia that took 8 years and $25 billion to achieve. But after the 6th and final Apollo mission ended in 1972, why haven't we ever been back? During the Kennedy era, the motivations to dominate space were strong, but the technical obstacles were even stronger. They were in fact so great that some people believed NASA broadcast a live publicity stunt of the moon landings. Amidst the turmoil of the Cold War, the United States and Soviet Union competed for military and technological superiority. Out of the missile-based arms race between the two nations grew the battle for spaceflight capability. And in 1961, the USSR humbled America when Soviet cosmonaut Yuri Gagarin became the first man in space. If America was to claim interstellar supremacy, it would have to do something truly momentous. In 1976, 4 years after Apollo 17 made the last journey to the moon, a technical writer called Bill Kaysing, who had access to NASA's spaceflight documents, claimed that the moon landings were in fact a hoax. In his book, We Never Went to the Moon, Kaysing calculated that the chance of a successful moon landing was as small as 0.0017%, because NASA lacked the technical capabilities to fulfill the mission. Nexus publisher Marcus Allen agrees with Kaysing that the difficulty is not getting to the moon, but getting people to the moon. And the main thing stopping us is the James Van Allen radiation belt. This is a layer of charged particles held in place by Earth's magnetic field. In order to reach the moon, Apollo astronauts would have to pass through this belt without any lead shielding on their spacecrafts, exposing them to fatal levels of radiation. For these reasons, it's suspected that the footage from NASA's interstellar missions is entirely staged, that the 1969 moon landing and the 5 that followed were actually filmed within a large soundstage at a Hollywood studio, with production funded by the Walt Disney Company. A moon landing hoax would be significantly cheaper than actually attempting to send astronauts into outer space, and if the footage was convincing enough, then it would still alert Russia to America's technological prowess. It's even been suggested that filmmaker Stanley Kubrick was behind Apollo missions 11 and 12. During the production of his 1968 movie 2001: A Space Odyssey, a whole year before the first moon landings, it's thought that Kubrick was secretly approached by NASA to direct the space missions, and employ the film's advanced special effects to replicate the moon's landscape. Close critiquing of the footage has led skeptics like Kaysing and Allen to refute the official story even further. We only have to look at the background of the NASA photographs. In the moon landscape snaps, there are no stars, where millions of twinkling lights should be. The flag appears to be moving by a slight breeze as it's planted in the ground, despite the fact there is no wind on the moon. And this rock, which seems to have the letter C written on it, gives the impression that this and other rocks are props labelled by a set designer. To create the illusion of low gravity, it's been claimed that the footage was played back 2.5 times slower. When you increase the film speed, the astronauts appear to be moving to Earth's gravity, and the jumps, it's assumed, were created using hidden cables, easily disguised against the black backdrop. Skeptics have also pointed to the moon landing site itself. There is no observable blast crater underneath the lunar module. With evidence mounting through the decades, it's no wonder that between 6 and 20% of Americans believe that the moon landings were a hoax. But for every bit of proof that the missions were staged, there are countless rebuttals from NASA scientists and filmmakers, in addition to third-party evidence that refutes the theory. The Lunar Reconnaissance Orbiter and other satellites have captured photographic evidence of the lunar landing sites. Hundreds of scientists and geologists, independent of NASA, have analysed the rock samples retrieved from the Apollo missions and confirmed that they are lunar sediments.
When we actually descended the ladder, it was found to be very much like the lunar gravity simulations we had performed here on Earth.
And as for suspicions over the footage, filmmaker S.G. Collins explains that the camera technology required to fake the moon landings simply didn't exist in the 1960s. As for the moving flag, it was merely shaken when it was planted in the ground. It may be hard to believe, but in the mid-20th century, it was indeed easier to send a man to the moon and film it than fake a televised space mission.
It's one small step for man, one giant leap for mankind.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made. I just can't tell you how proud we all are of what you... For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure they too join with America in recognizing what an immense feat this is. Because of what you have done, the heavens have become a part of man's world.
The suggestion that NASA faked the Apollo missions goes back to the very first time Neil Armstrong walked on the moon. Some believed he never really went. Others believe that he did make it, but the famous footage and photographs are fake. To find out more about how and why the landings might have been staged, Second Thought has made this video for you. Please check it out, it's great. In the meantime, in this video, we'll consider the fact that if the footage were faked, someone had to fake it. And the best suspect is legendary director Stanley Kubrick. What's more, he may have left clues that expose the greatest hoax in history. Not only was Stanley Kubrick an artistic genius, but he was a technical wizard. His groundbreaking film, 2001: A Space Odyssey, made him the obvious suspect to fake the moon landings. It came out in 1968, over a year before the Apollo 11 landing. Yet its depiction of weightless space travel is still hailed as the most accurate in cinematic history. Kubrick is known as the most meticulous filmmaker ever, and he worked closely with NASA and aerospace engineers. The spaceships and spacesuits were designed in line with actual space travel technology. Images of the moon were constructed using NASA's best maps of the surface, which is why they still stand up today. The film features extensive sequences set on the moon, which use miniatures and front-projected matte paintings to recreate the process of landing and walking on the desolate moonscape. Theorist Jay Weidner says a close examination of NASA footage and still photographs reveals the same camera tricks were used as in Kubrick's sci-fi epic. He believes that Kubrick was hired by the US government to stage the moon landings using the technology and equipment he perfected on 2001: A Space Odyssey. Furthermore, Weidner says Kubrick subverted his vow of secrecy by hiding clues to the truth in his 1980 horror masterpiece, The Shining. The most obvious allusion to the moon landings is in this scene, where young Danny Torrance is playing in the Overlook Hotel. He is wearing an Apollo 11 sweater, and as he stands up, it is like the rocket is taking off. This is probably a deliberate visual gag on Kubrick's part, given the specially designed carpet of the hotel has a geometric pattern similar to Apollo 11's launch pad. With this in mind, Jay Weidner argues there are many more references to NASA's lunar program littered throughout the film. The food supplies in the hotel include Tang, a powdered fruit drink used by NASA on its manned spaceflights. More subtly, the number 11 and the letter A are hidden in shapes throughout the sets. And the Native Americans on the tapestry to the left look suspiciously like Saturn V rockets, the same ones used on the Apollo program. The film begins with the main characters, Jack, Wendy, and Danny Torrance, driving along the Going to the Sun road in the Rocky Mountains. The classical god of the sun is Apollo. Later, when Jack Torrance meets the manager of the hotel, we can see two eagles in the office. Also, Jack's typewriter is a German Adler, or eagle, machine. The symbol of the Apollo missions was the American bald eagle, and the lunar module itself was named the Eagle. Meanwhile, the manager's outfit, comprising of red, white, and blue clothing, means he represents the government. Jack Torrance, on the other hand, is an author, an independent artist looking for a job to support him and his family while he works on his next project. In other words, Jack represents Stanley Kubrick, and the manager represents the government hiring him to work on the Apollo program. The pressure of the huge task gets to him and puts a strain on his marriage. Jack's rant is therefore really Kubrick's feelings about the dark hoax he was forced to perpetrate.
Ever thought about my responsibilities?
Oh, Dick, what are you talking about?
Have you ever had a single moment's thought about my responsibilities? Have you ever thought for a single solitary moment about my responsibilities to my employers? Does it matter to you at all that the owners have placed their complete confidence and trust in me, and that I have signed a letter of agreement, a contract, in which I have accepted that responsibility? Do you have the slightest idea what a moral and ethical principle is, do you? Has it ever occurred to you what would happen to my future if I were to fail to live up to my responsibilities? Has it ever occurred to you? Has it?
As Jack types, all work and no play makes Jack a dull boy, and the nature of the work is hinted at in the typeface, A11 for Apollo 11. It is important to note that The Shining is adapted from the novel of the same name by Stephen King, but none of the allusions to the Apollo program were in the book. They were added by Kubrick as part of his changes to the source material. These changes included altering the book's Room 217 to Room 237. Jay Widener says Kubrick changed the number to draw attention to the moon landings. The average distance of the moon from the Earth is 237,000 miles. 237 is also, according to Widener, the name of the studio where Kubrick filmed the fake NASA mission. However, most of these illusions are hard to prove. The Shining is so layered and visually complex that it lends itself to countless interpretations, as demonstrated by documentaries and critics. Nevertheless, some of these supposed references to the moon are probably misinterpreted. For instance, the average distance of the moon from the Earth is over 238,000 miles. It seems unlikely that the meticulous Kubrick would make that mistake. In fact, the owners of the hotel used for the exterior shots have said that the room number was changed because the hotel had a real Room 217 and didn't want to discourage guests from booking it. In December 2015, filmmaker T. Patrick Murray published what he claimed was an exclusive interview with director Stanley Kubrick. In it, Kubrick says, "I perpetrated a huge fraud on the American public, involving the United States government and NASA. The moon landings were faked, and I was the person who filmed it." Kubrick's widow, Christiane, says the interview is a complete fabrication. The double in the video looks very little and sounds nothing like the real Stanley Kubrick. Furthermore, T. Patrick Murray has given no plausible reason why the notoriously private director would give him an interview, and why he kept the interview secret for 15 years after Kubrick's death. The director's daughter Vivian made a documentary using footage she filmed on the set of The Shining. In July 2016, she issued a statement strongly denying the theory that her father faked the moon landings. She argues that he had too much artistic integrity and distrust of government lies to ever want to help them carry out such a gigantic hoax. Despite claims to the contrary, Stanley Kubrick never said he faked the moon landings. The people who knew Stanley Kubrick best, his family and colleagues, all say he never did it, and it never would. Meanwhile, theories about clues he planted in The Shining only work if you interpret the film one particular way. This hasn't stopped other books and films being inspired by the theory. There is something interesting in the argument that Kubrick's filmmaking tricks were used by NASA to construct the Apollo 11 footage. However, NASA insists the footage is real, as do the Apollo astronauts. Moreover, so does the great director himself.
Hi everyone, and welcome to yet another controversial Better Mankind video. I think subconsciously there must be a part of me that enjoys the onslaught of nasty comments when I make videos like this. But the fact remains that there's way more evidence that supports the theory that we never went to the moon than there is to support that we ever did. Now, there are many reasons that prove we never went to the moon. To mention a few, you have the wavy flag in a zero atmosphere environment, the lack of any blast crater underneath the lunar module, or how about the absence of stars in space? The problem with any of these arguments is that NASA seems to have an explanation for every single one of them. Therefore, people like me and other moon landing deniers are referred to as a bunch of crazy tinfoil hat-wearing conspiracy kooks that need to up their medication. So in this video, I'm only going to address a single discrepancy that NASA themselves have admitted to on more than one occasion, and will prove without a doubt that we have never even left low Earth orbit, let alone landed a man on the moon. But first, let's go back to school and get a refresher course on the different atmospheres surrounding the Earth. Now, the following information is critical to proving my point, so please bear with me. First, we have the troposphere. This is where all of our weather occurs, and it is the lowest layer of the Earth's atmosphere. It starts at the Earth's surface and extends up to a height of 4 to 10 miles. Next, we have the stratosphere, which extends to about 35 miles above the Earth's surface. This is where our ozone layer resides and protects us from those dangerous UV rays. It is also the layer where aircraft travels, as it is free from weather disturbances. Now we go up to the mesosphere, where most meteors burn up on entry. The mesosphere stretches up to 50 miles above the Earth's surface. Next we have the thermosphere, and this layer extends up to 400 miles from the Earth's surface, and the air here is very thin. Also, temperatures here start to get really hot, ranging anywhere from 200 to 500 degrees Celsius and 500 to 2000 degrees Celsius in the upper region. And last but not least is the exosphere. The temperature in the exosphere can vary from 0 to 1700 degrees Celsius. The exosphere is the outermost layer of the Earth's atmosphere and is around 6,200 miles from the Earth's surface. Now, according to NASA, low Earth orbit is around 1,200 miles from the Earth's surface. So before I tell you the reasons why it is impossible for us to go beyond the exosphere, or for that matter, even past the thermosphere, have a listen to what some NASA experts have to say about this topic.
As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space.
Hang on. So what you're saying is that in order to send humans through this region, we need to solve the challenge of getting through the Van Allen radiation belts. But I'm confused. Didn't you already solve this challenge back in 1969 when you sent astronauts to the moon, and subsequently 5 other times after that?
But we're also really pushing the boundaries in terms of where we're going forward with exploration. I think humans are naturally driven to do this, and this is really the beginning, I think, of human beings leaving low Earth orbit. I certainly plan on being around to see that.
So she's a NASA astronaut, but I guess no one bothered to tell her about the first time that we left low Earth orbit. I guess she might be a little too young to remember. Here we have another astronaut that wasn't told about the moon landing 48 years ago.
The plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to, and we're building these building block components in order to allow us to do that eventually.
Once we travel beyond low Earth orbit, the crew will be exposed to larger amounts of radiation. So we have to design both the crew protection systems and our electronic systems to withstand this radiation.
So that would mean that Neil Armstrong, Michael Collins and Buzz Aldrin were a tough bunch of SOBs, able to withstand all that brutal radiation, considering these challenges are still yet to be solved. So how is it that we had the technology to achieve this amazing feat back in 1969, but we're still working on the technology in 2017, almost half a century later? Well, I managed to find a very clever and well-informed astronaut that will totally straighten things out for us and explain exactly why we're not able to return to the moon and break through those Van Allen radiation belts. Have a listen to this clever chap.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
This guy, oh boy. Here's a real-life example of what can happen to you when you're exposed to all of that outer space radiation. And if you're a child with aspirations of becoming an astronaut, being a very good liar might be a positive attribute to have on your resume. Now, just by showing you these admissions of guilt by NASA, I can easily end this video now, and I would have easily proven my point without a shadow of a doubt. But I'm sure that for some of you hardened skeptics out there, this damaging evidence is still not enough. So let's take this theory of mine to the next level. This here is the lunar module now proudly displayed at the National Air and Space Museum. According to NASA, the primary materials used to build the module were aluminium alloy, stainless steel, titanium, nickel steel alloy, heat-resistant glass. Now, if this is the case, we have a very serious discrepancy here. If you remember earlier when I went through the different atmospheres that surround the Earth, both the thermosphere and exosphere have temperatures ranging from 0 to 2000 degrees Celsius. So I decided to examine the melting points of the primary metals that were used to build the lunar module. First off, we have the aluminium alloy, which has a melting point of 463 degrees Celsius. Next we have stainless steel, which has a melting point of 1510 degrees Celsius. Then we also have nickel steel alloy, which melts at 1453 degrees Celsius, and of course the heat resistant glass for the windows, which has a melting point of 760 degrees Celsius. So this would mean that the lunar module, along with its occupants, would have disintegrated well before it even passed through the thermosphere, let alone surviving the Van Allen radiation belts in the exosphere. To protect the astronauts from the Van Allen radiation belts, the lunar module would have required 6 feet of lead shielding. But here's what they really had for protection.
Obviously, the only shielding they had was the literally paper-thin outer hull of aluminum, and their suits consisting of glass fiber, some aluminum fibers, and silicon rubber.
It's very interesting concerning radiation that the astronauts were protected by a thin film of aluminum when here on Earth they put a lead shield on us when they take a dental x-ray.
In conclusion, when NASA themselves admit to never having left low Earth orbit, and the fact that we don't even have the materials that could withstand the extreme temperatures and cosmic rays in space, how on earth can anyone believe that we ever went to the moon? Well, I hope you enjoyed this video, and if you like my content, please give me the thumbs up and subscribe to my channel. Also, if you have your own opinions about the moon landing, feel free to leave me a comment and let me know your thoughts. Until next time, take care and be good to each other.
That this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
Hi, I'm Matt, and I don't believe we landed on the moon. I am not a conspiracy theorist. I don't have any real hard opinions on JFK. I don't necessarily think Bush did 9/11. I don't believe that the government is putting chemicals in the sky. What are other conspiracy theories?
Area 51.
Oh, I do kind of think that something happened at Area 51. I got into reading up a lot on conspiracy theories, and a lot of the times it's all baloney. I go in specifically to debunk them, and I did so with the moon landing. So I started to read more stuff about the moon landing. After I started to debunk certain parts of it, there were some things that I couldn't explain. I don't think that we landed on the moon in 1969, or ever. Motives. Let's start with the motive of why the US government would have faked the moon landing. Cold War is number one. We were at it with the Russians. JFK came out in 1961 and said, you know what, by the end of the decade, we're gonna go to the moon. And then therefore, we had to do it. That's JFK, that's our guy. And we supposedly beat them. We didn't. There were concerns that Russia was gonna build a missile base on the moon. Sounds crazy, but it's not. And it's what people believe. As that decade progressed, we are not making the strides that we see Russia making. They put Yuri Gagarin out into space before we did, and that was scary. There's a lot of going on here. We have the Van Allen belts, lost cosmonauts, Gus Grissom, crosshairs, we'll get there, competing shadows. My theory is we didn't really have the technology to do so. Look at the computers that they were using in the mission control. They were like 16-bit computers. They were like TI-83 calculators. We're in this race. We are running up against an issue with the Van Allen belts. The Van Allen belts are these radiation belts that kind of exists here. It's radiation, and that would tear up the human body. NASA was having a really hard time trying to figure out how to safely send someone through the Van Allen belts. Russia knew that we didn't, but couldn't say, you guys don't know how to get people through the Van Allen belts, and we know because we don't either. Russia, quietly failing to send people through the Van Allen belts, had killed a number of people. Gus Grissom was one of the original astronauts on the Apollo mission. He was originally going to be the first man on the moon. There's a conspiracy theory that NASA murdered Gus Grissom. He was publicly critical of NASA's success and ability to reach the moon. They needed him quiet. Right there, 1967, Gus Grissom died. The failed Apollo 1 mission in which Gus Grissom, Ed White, and Roger Chaffee died in a fire before launch. There are a lot of discrepancies based on the footage of the moon landing. And a lot of those I don't necessarily believe are good, hard arguments. What can't be explained away is the crosshairs on the photos. In the images of the NASA moon landing, these are photos that NASA took and released. There are moments where the crosshairs, which are fixed to the camera, actually lie behind equipment. The theory is that the only way that the crosshairs would be behind a piece of equipment in a photo would be if the piece of equipment was superimposed. This happens on a couple of occasions in the NASA photos, and to me, I don't know how you get around it. Say this is the photo of the moon. We got the rocks and the moon here. Let's say the sun is over here, right? Well, we got shadows naturally this way, but in some occasions, there are shadows competing. This would suggest another light source over here, sending the shadow this way. If you're on the moon, there wouldn't be two light sources, there would only be the one, the sun. The lack of artifacts. The easiest way to prove that we've been to the moon is to show people the things on the moon. However, everyone insists we don't have telescopes big enough to see the we put on the moon. The going argument is that to be visible from our best telescopes, something would have to be a little bit larger than a small house. That's nuts. A lot of people suggest that the footage is just slowed down half speed. We shot it in a Hollywood studio, jumped around, drove a lunar lander around sand, and then just cut it by half the speed. You take the actual footage from the moon landing, you do double speed, it looks almost exactly like a normal car driving around on a beach. Really very interesting. Look into it. A lot of people have recreated the footage. It's very easy to do. BuzzFeed has done it. Did it almost exactly and perfectly. I recognize that this looks like the ramblings of a crazy person. People look at me like I'm crazy, they're whispering, I hear it, they go, ooh, he's nuts. Do your own investigation, come up with your own conclusion. And I think that you might find that that conclusion leads you to believe the moon landing did not happen.
The moon orbits the Earth at 384,000 kilometers. What would it look like if the moon orbited the Earth at 420 kilometers? The same distance as the International Space Station.
Good evening, folks. Ken Hovind here and the crew at Dinosaur Adventureland. It is June the 27th, 2017. Okay, question sent to me from Rhonda. No, that's the secretary. Sent to me from Ryan. There we go, via Rhonda. Let's see, Brother Hovind, could the distance the moon moves from the Earth be growing over time? Excellent question, Ryan. I have my PowerPoint videotape number 1 of my seminar. I talk about one of maybe 100 different ways to prove the solar system and universe cannot be billions of years old. It cannot be. for lots of reasons. Let's suppose George is accused of a crime, and they got 100 pieces of evidence that says he's guilty. But he's got one piece of evidence that proves he was not even in the country when the crime was committed. Oh, bingo, it's all you need. One piece of evidence, he's off the hook. If there's one proof of a young Earth, the argument's over. It has to be young. The atheist or evolutionist or old Earth creationist has to answer every single one with a logical, coherent answer. And there could be 50 ways that they think they can show the universe is old, but only one to prove it's young would, in a court of law, would seal the case. Now, the moon is going around the Earth, and the moon is round and the Earth is round, contrary to the stuff going around. But, by the way, we're going to have an eclipse coming soon. Okay, here is the Earth. Where's a moon here? I need a moon. Little ball. I should have got... Perfect, there we go, a clam. A hickory nut, okay. The moon is about 1/4 the size of the Earth in diameter, 2,160 miles, I think. It's been a long time. And the Earth is a little less than 8,000 miles in diameter. If the sun is the camera, as the moon goes across under the sun, it makes a shadow. A little bitty shadow about, I don't know, 50, 60 miles wide on the Earth, called an eclipse. And the people who happen to live under that, on that stripe, where it goes, don't get to see the sun for a while. People that live on the other sides of it, they get to see it just fine. People that live on the edge might see a partial eclipse. So there is an eclipse coming, and people have been looking at the moon for a long time. I mean, like since the creation of Adam and Eve 6,000 years ago. So the eclipse of the moon, they've been studying this topic for thousands of years, trying to calculate the distance to the moon, about 240,000 miles. It has been pretty well proven the moon goes in kind of an oval around the Earth. Gets a little bit closer at times and a little further away. When it's a little further away, they call that apogee, A for away. When it's close, it's perigee, P for pretty close, okay? It's only a few thousand miles different. But that oval is gradually enlarging. The moon is leaving us. It's getting farther away. The Institute for Creation Research, ICR, in California, puts out a monthly newsletter called Impact Articles. They're excellent. Young age for the Earth and the moon. This is Impact Article number 110, which would have been August of 1982. Okay, so they put these out for a long time. ICR.org, a great organization. They they show in here that, hey, the moon is leaving the Earth, which people have known for a long time. Now, it's not leaving by much, but your question is, could it have been greater in the past? And the answer is absolutely yes. If two objects are attracted to each other by gravity, like the Earth and the moon, the closer they are, the stronger the pull is. But it's not just a simple straight line. If you brought, let's say they've got 1,000,000 pounds of pull between them at this distance. If you half that distance, you take that fraction 1/2, flip it over, and square it. It is 4 times the pull. At half the distance, it'd be 4,000,000 pounds of pull, or however you want to measure it. If you brought it into 1/3, it would be 9 times the pull, not 1/3 the pull. It's called the inverse square law. And we cover that on video number 6 of my series. So that's Simple Physics 101. It applies to gravity, light, magnetism, and girls. You get too close and you can't stay apart. So never mind. Okay, so here's curious.astro.Cornell University just a couple years ago. The moon's orbit, its circular path around the Earth, is indeed getting larger at a rate of about 3.8 centimeters. That's 1.5 inches per year. So the folks at Cornell University are saying, hey, the moon is getting farther away from the Earth, about 1.5 inches a year. I've never had anybody argue that this isn't true. I think this is obvious. The moon is leaving us. So what does that mean? Well, if you brought the moon in closer, because of the inverse square law, the attraction is much greater. So if the moon were millions of years old, it would have to be whizzing around really fast around the Earth just to stay in orbit, because the gravity would be so much stronger. And it couldn't go that fast. People that have studied this say about 1.2 to 1.4 billion years is absolute maximum for the age of the Earth-Moon. If you go back in time, here's today, go back 1 billion years. Indeed, the rate the moon left us would have to be greater in the past. It would go out faster and then slow down in its recession rate. So who cares? Well, 1.4 billion is absolute max when the moon would make contact with the Earth. Way before that, you're going to have several problems because the moon causes the tide. The closer it is, the higher the tides are going to be. It's going to pull the tides way up and drown everything on Earth twice a day. Except for the fish, they would like it. Also, there's what's called a land tide. When we turn under the moon, it actually lifts up the whole United States about an inch or two. We don't feel it because the whole country goes, the whole crust of the Earth goes at the same time. So the oceans, you can see it go up. Now, what's the tides up where you in South Carolina where you were, Mary? Did you?
Yeah, I don't know.
Pensacola, the tide's not much, you know, what, foot and a half. You get up to the
maybe 3-4 feet.
3 feet in South Carolina. See, that's the Atlantic, not the Gulf of Mexico. You get up at the Bay of Fundy in Canada. I was up there preaching a couple times, just because of the way the water, as the ocean pulls up, it goes into this bay called the Bay of Fundy, and it goes up 60 feet. Wow. Up and down 60 feet every 6.5 hours. Over in Alaska, I preached up there in Alaska, that tide goes up in in Anchorage, Alaska, 30 feet tidal change. It varies depending on the coastline. But the moon is causing that. Okay, if you went back in time and brought the moon closer, all of this would be much worse. Now, those who want us to believe the Earth is billions of years old have got to have a logical, coherent answer. And you need to contact Cornell University while you're at it and say, look, the Earth is billions of years old. Okay, how could the moon have been going around the Earth when the maximum time limit is, right there, 1.4 billion years. They're going to tell you kids in school that the Earth is 4.6 billion years old. Well, then where did the moon come from? There are several theories that have been proposed over the centuries, like your chicken and the egg song. They'll have 30 theories of how the chicken came to be. Everything is acceptable as a theory, except God did it. They don't want that. Any other theory they'll take. So I think it was, who's the famous atheist that said a reptile laid an egg and a bird came out. Was that Stephen Gould or, I forget. Okay, a reptile laid an egg and a bird came out. That's how the birds got started. Well, that raises several problems. How come we never see this today? Where's all this new genetic code coming from? And who did this first bird marry?
Who was his daddy?
Huh?
Who was his daddy?
Who was his daddy? Yeah, there we go. So the moon, the theories about how we got the moon up there are several theories. All of them fail on their face. One theory is it's captured. It came flying in from space and it just happened to be the right angle to get caught in our orbit. Tell you what, you hold one magnet, a south pole, I'll get a north magnet, I'll throw it at you, and I want you to catch it in orbit so that the attraction is the same as you're swinging it around centrifugal force. The chances of that are 0. It's called the capture theory, been proven wrong years ago, scientifically impossible to happen. The other theory is the ejection theory. A piece of the Earth broke off and went flying out into space, and that became the moon. There are hundreds of problems with that. For instance, the moon doesn't have enough gravity to pull itself into a perfectly round ball. And the moon is nearly perfectly round. I don't know how close to perfect it is, but it's a lot closer than the Earth. Earth bulges about 20 miles. The moon is real close. And it's just, there's the physics behind that is impossible. They've got several theories of how we got the moon, all of them except God made it. Seem to be acceptable. So thank you for your question. Yes, the answer is the moon would be leaving us. The evolution of the lunar semi-major axis presents a well-known timescale problem. The lunar orbit collapses only over a little over 1 billion years ago. This is Astronomical Journal way back in 1954. They knew this. Republished 1994. It's 1994, page 1954. But they've known of this problem for decades. The moon is leaving us, plain and simple. What does that mean? Well, if you brought the moon in closer, you create a problem. They want you kids to believe dinosaurs lived millions of years ago. Well, then the moon was whizzing around just above the surface of the Earth. So that explains what happened to the dinosaurs. They got mooned. No, okay, that's a joke, Hannah. It is not possible for this system to be billions of years old. If you need billions of years to turn your chicken into, or turn your reptile into a bird, I understand your problem. I sympathize with you. If you need billions of years to make it look logical for a frog to turn to a prince, I sympathize with you. I understand. That is a problem. It didn't happen, okay? God made the chickens. Not the eggs. He made the chickens to lay the eggs. He made the trees, and they produced the fruit. He made Adam and Eve. Had to be a mature creation. Okay, we got one question done, Lady Di, and that's all the time. Oh, well, we're done. I got a whole stack here. We'll get to more when one of my brothers straightens up, but he's a hunchback, so that might be a while.
I got a question for you, man. Okay. So, I've been a fan of you for a long time, right? So what? Thank you. Appreciate it. I appreciate you. Appreciate it. What what made you make the switch from like being a moon landing denier to like you crazy if you don't?
No, I don't think we're crazy. No, this is my take on it. Absolutely, I don't know enough about astrophysics, about space travel, about the science that's the work that's been done about how to get a rocket to the moon and back. I definitely don't know enough.
It's rocket science.
And I've looked at a lot of very compelling documentaries that explain why they think it was hoaxed. And they'll show you some footage, and you can look at some of the footage, and it looks fake as f***. There's some footage that, to me, looks really doctored. There's
to this day?
Yeah, to this day. Okay. There's some when you ever seen ones where it looks like they're on wires, like the astronauts are on wires?
I have.
There's some where there's a video where they look like they're on a trampoline. They're bouncing around on trampolines. Mm-hmm. The physics are different in different videos. This is where it gets weird. Like the physics are different from the Apollo 11 moon landing. We see them waddle around on the surface of the moon. They're moving at like half speed. And then you see them in other ones, like the one where they bounce around the air. You're like, wow, they're moving different. They're in the same thing, but it looks different. The first one was very grainy. They showed it on a projection screen. Right. There's a couple different possibilities. One possibility is it just looks weird because it's on the moon and your brain is trying to interpret it and your brain's going, well, that's fake, because you don't really understand what 1/6 Earth's gravity really does to a body. That's one possibility. Yeah. Another possibility, which has been shown to be true, is that some of the stuff that they passed off as being legitimate photographs of space travel was actually test runs where they blacked out the background and pretended that they were in space. And there's one really clear example of this. It's Michael Collins. Michael Collins, who was a guy who was aboard Apollo 11. Right. And Gemini 15. There's a photo of him in the middle of a what is it when they walk around outside the spacewalk? They call it a spacewalk? Yeah. Why does that seem like a bad word? It's like spacewalk. Like it doesn't seem like that's the official title. Well, it's in the middle of a spacewalk.
It's probably something more.
Yeah,
a little more syllables.
Yeah, something slicker. Anyway, so he's doing the spacewalk and he's got this harness on. He's holding on to this like thing, and it was apparently just an image that had already been published of him in a training exercise, and they blacked out the background and flipped the picture upside down.
That's the joint right there.
It's the same exact photo. Same exact photo. I mean, people have lined it up and switched it over. It's the same photo. It's just been edited. So the one on the left was them practicing how to use these. I don't guess that the harness is some sort of a thing that he's hanging on to. I guess it moves him around a little bit. Right. They were trying to practice it on the left, and on the right, they just passed it off. But those are publicity photos, right?
Right.
So you got to go, well, okay, well, who approves of publicity photos? It could easily be just some idiot who works in the publicity department who did marketing, who didn't think they had enough photos from the moon that were good of spacewalks. It's probably insanely difficult to take a spacewalk photo. Right. So does that mean that they faked the moon landing? No, but it means that people fake things. So you got to got to be really objective and looking at that. Right. Okay, so people say fake things. They definitely filmed a lot of the training exercises that they did of the moon landing. Right. They filmed a lot of shit. They definitely did. If that has already been proven that they took this fake photograph and they tried to pass it off as a real spacewalk, it's entirely possible that some of the stuff that they filmed, they made out to look like they were on the moon when they were not. But does that mean they didn't go to the moon? No, it doesn't. And so when I was saying it proves that they didn't go to the moon, my critique of myself is that I didn't look at it objectively because I wanted one conclusion to be true, and I wanted that conclusion to be that the moon landing was fake. So I looked at it and I was saying to myself, okay, did I come to this conclusion because there's a lot of evidence that shows it to be fake, or have I seen a lot of evidence that looks fake? And does that mean that they didn't go to the moon? Right. No, it doesn't. There's a bunch of different possibilities. There's a ton of different possibilities. There's also the possibility that whatever photographs they took can get severely damaged in the radiation of space, and that it was really difficult to do.
Right.
That's possible too, and that they decided somehow or another that they were going to pass off these, that they actually did go, and they're deciding they're going to pass off some of these fake videos. So there's a bunch of possibilities. The possibility that it looks fake because I'm dumb, and because I don't understand anything about the physics of 1/6 Earth's gravity, and it just looks weird because it's film, it's 1969. That's possibility number one. Number two is they fake some things. Or number three is they didn't really have good footage because, like, you couldn't take film through the airport. Remember that?
Yeah.
Like, people would go through those radar detectors, and your film would get jacked, and they weren't responsible.
I didn't have any film, but I know
people that I have friends that are photographers, and my uncle's a photographer, and he would tell me you can't send the film. Like, if you have you take a roll of film and awesome pictures.
How would they get it through?
I don't know. I don't know what the they did, but I know that some film has been damaged, or maybe it's an urban myth. Maybe find out if film got damaged by those radar things at the airport. X-rays at the airport.
I could appreciate the mindset though of looking at your opinion objectively and saying, "Am I tripping? Let's look at the facts and say, I'm just not really sure." I think that's the problem with people today, and people period, is that they're afraid to say, I don't know.
Yeah.
You know what I mean?
They're super afraid.
It's like, to me, ignorance is such a gift. Like, it just gives you an opportunity to learn some shit if you're humble enough. Like, don't assume you know shit. Even if I feel like I know, I still feel like I don't know.
Yeah, well, that seems you have a very healthy ego for a big, young, and super athlete.
It's football, man. Like,
I know, but I'm saying your ego is very healthy. You have a really good way of looking at things. I think that's the right way to be, man. You can't be married to like ideas and opinions like that because they're not you. But we think that they are. They're like an extension of us. So we want to win these arguments. We want to be right. I think it gets real scary when you want to be right, and then you're willing to ignore evidence that might show that you're wrong. Right. And that's how I felt about myself. And by the way, if you wanted a conspiracy that's a good one, that seems like it might be possible, the moon landing is one of the best ones, and this is why it's so attractive. Between 1969 and 1973,
you still on the fence about this, huh?
No, I'm not at all.
Okay.
But I'm on the I don't know fence. That's where I live.
All right.
But between that time,
got a lot of facts on this side. I'm with you though.
They sent, I think it was 7 missions. 6 of them were successful. The only one that wasn't successful was Apollo 13. Right? They sent these fucking people around the moon, 250,000 plus miles out there and back. But ever since then, all they've been able to do is get people into near Earth orbit. Ever since then, like the highest anyone's ever gone, I think it's 400 miles. So they went from 260,000 miles all the way to the moon and back to 400 miles. Everything is like inside. And they've never gone through the Van Allen radiation belts. They've never gone into deep space and returned. They haven't done that since 1973.
I thought, and I could be wrong, but I thought it was because of like funding.
Could be.
Like, because,
meanwhile, LACMA's got funds. Show me how that makes sense. You don't want to fund space travel. You want to fund that acrylic box.
Amber box. Great adjective, by the way. That's perfect.
It is a great one. I don't think that I know whether or not we went to the moon, but I'm telling you that if you wanted a juicy conspiracy to get excited about,
I've looked into it.
It's the best one to get excited about. They lost all the data.
I see, because like I see, like, you go down the YouTube wormhole. I start watching Barry Sanders highlights, and then all of a sudden I'm looking at JFK being Michael Jackson or some shit. But like, I just don't see what the motive would be. Like, what is the fucking like?
The Cold War. First of all, we wanted to beat the Russians because we were in a race to see who can get to the moon. And here's one of the things that we do know for a fact: the Russians faked a bunch of shit. They faked a bunch of footage. Yeah, Yuri Gagarin, who was the first man in space. They had a video.
You might be an expert on this, man.
I studied this. I debated a guy who was a really nice guy, but Phil Plait, who's a bat astronomer, batastronomer.com.
Okay.
And he was a lot of things he wasn't willing to admit, though, that were unfortunate, because maybe he could have convinced me more if he was. And one of the big ones was that Werner von Braun was a Nazi. They hired a bunch of Nazis to run the space program. It was called Operation Paperclip. And what Operation Paperclip was they took a bunch of Nazi scientists and relocated them to the United States. We lost some of them to Russia. Russia scooped up some of them. But when we ended the World War II and Nazi Germany collapsed, we went in and took the scientists. Well, Werner von Braun was the head of a rocket factory in Berlin, where they used to hang the 5 slowest Jews in front of the rocket factory for all the other workers to see. Werner von Braun, the Simon Wiesenthal Center said, if Werner von Braun was alive today, he'd be punished for crimes against humanity.
This is news to me.
No, Werner von Braun was a straight-up Nazi. And this guy was not willing to admit that.
Right.
It's like, well, just because someone's in Germany. No. No, he was a Nazi. He was a Nazi. Whether or not he actually killed anybody, maybe he had to be a Nazi.
Right.
I mean, we're not saying that, look, if you're f***ed and you're in this neighborhood and that it overcomes the entire neighborhood, you want to keep your family alive, so you put that thing on your jacket sleeve, you put that swastika on, and you Sieg Heil like everybody else. Maybe you're not really a Nazi ideologically. Maybe you're not a Nazi in your heart. Maybe you're just trying to stay alive. That's entirely possible too. But he was a Nazi. He was a Nazi. And they had slaves that were running rocket factories in Berlin where they were figuring out how to make rockets.
That's brand new. I need to.
Yeah. Operation Paperclip. Cold War, President Truman authorized Operation Paperclip in August of 1945. The U.S. It secretly admitted 88 German scientists and engineers to help in development of rocket technology, including Werner von Braun, Arthur Rudolph, and Hubertus Strugold. Hubertus. That's a great name.
It's not a great name, bro.
Bring that back. Hubertus. If you have a stud kid who's like one of the strongest men in the world, his name is Hubertus.
He's named after
that's
a
my
Nazi.
son, Hubertus. Oh, that's true. That's true. He's named after a Nazi. So there was like something in the debate that guy was not willing to admit, which made me even more skeptical that he was right about the other stuff. The other thing was that moon rocks that they've collected from the moon have turned out to not really be moon rocks. Like a bunch of them for sure have been tested by scientists and they've found that these rocks are from another planet. But there was a rock that they gave to whoever's the head of Holland, and it was personally given with a plaque by Neil Armstrong, Buzz Aldrin, and Michael Collins, and it turned out to be petrified wood. Moon rock given to Holland by Neil Armstrong and Buzz Aldrin is fake. It's a moon rock given to the Dutch Prime Minister by the Apollo 11 astronauts in 1969, turned out to be a fake. So they were giving people pieces of petrified wood saying, this is for you, we went to the moon, God bless America.
With 308,000 euros.
Now, there's a bunch of possibilities, okay? Let's just be honest about this, because this story is from 2009. It's entirely possible that between 1969... there's multiple sources, but that's the Telegraph.
That's
a legit newspaper.
But you got to trace the source.
For sure. What I'm saying is that it's entirely possible that someone stole that moon rock and replaced it with that. That's possible.
All right.
That's possible. Or it's possible they just had some fake rocks. Here's the thing. Bill Clinton had a quote in his book, in one of his books. I think his book is called My Life. And he had a quote about the moon landing and a story about him having this conversation with a carpenter. And that this carpenter said that he didn't believe the moon landing. He goes, them television fellers, they can make anything look real. And he said, this is a quote in Bill Clinton's book. He said, back then I thought that guy was a quack. But or a crank, whatever, crazy person. But after 8 years in the White House, I was wondering if he wasn't ahead of his time.
Oh, wow.
This is a guy that was the fucking president of the United States. And he's talking specifically about an old carpenter telling him the moon landing was fake. And then he says, I wondered after 8 years in the White House if that guy wasn't ahead of his time.
Causation, correlation.
Yeah. No, look, could be bullshit.
Yeah.
Could be bullshit. 100%. It could be just a good story.
But I think that's the thing about conspiracy theories is like they lead you on all these dead end chases.
Oh, yeah. Well, what's weird is that Trump's a conspiracy theorist.
There's a lot more adjectives you can add on to that.
Yeah, but the conspiracy theory aspect is interesting.
As far as what can be confirmed.
You know he's going to want to know about UFOs. That's probably like the first he did. He probably sat them down. What's going on with the aliens? Where do we stand?
He has an interest in that?
Where do we stand?
Like,
Who doesn't? You wouldn't?
I would guess it. I do, for sure.
I do.
I don't think we have been visited.
Come on, dude. Let me tell you something.
Okay, tell me something.
You become the president.
All right.
President Foster, how are you, sir?
I'm well, man.
What would you like to do today? I'd like to find out if there's aliens.
Nah,
it's my
man.
first day on the
That
job.
was my first one, man.
No?
Nah.
First day on the job. I'm like, take me to the bodies. I need to know what the we're up against. Are they real? I need to know.
There's no way.
I would need to know. If you knew that there might be a possibility that they knew, you sat down with all the
I definitely had to ask you.
Yeah. If you heard rumblings, if you and Mike Pence were in the elevator, Mr. President.
He wouldn't be my vice president, man.
Okay, who would your vice president be?
Not him. Not Mike Pence, but yeah, we on the elevator.
Who would it be?
You.
I don't want to be vice president, dude.
Oh, bro.
No. That means you get shot if you have to be president.
I get Sam Harris, man.
That's a good one.
That's my guy.
One. I would let him be president, though.
Have you had him on your...
Bunch of times.
Really?
Yeah, bunch of times. He's on in a week, too.
What's crazy is I'm subscribed to you on YouTube and keeps kicking me off, and I don't know what's going on with that.
That's the government trying to control me. They can't handle the truth.
Yeah, man.
So, to the long answer of your question, that's where I stood on this whole moon landing thing. That's why I came around to thinking it a different way.
Right.
I was way too convinced that I was right.
Right.
I'm convinced I was right, but and real low levels of understanding of any of the science of this stuff.
Yeah, I think that's the problem is as a society we're so scientifically illiterate, you know, and that causes so much room for speculation. And you're kind of a prisoner of people who are masters of their craft. You're kind of a prisoner to their quote unquote agenda. I don't want to put that bad of a term on it, but you're kind of a prisoner of that because we don't have any choice but to take their word for it or to pursue it yourself.
Right, to learn about what they're talking about yourself, to know if they're right or not.
Yeah.
Well, that's absolutely the case, right? Because you know that's the case in almost everything else. Like that was always like a real problem with martial arts, was there was this one dude who had all the information and you didn't know, and then you would listen to him say shit, and you're like, whoa, is that true? And you would think it was true. But now like there's videos you could watch on YouTube of like some crazy kung fu dude that's just talking nonsense. He doesn't really know how to do anything. He's just got some crazy thing about chi power, and if you don't know, you think this guy is real.
Yeah, 100%.
But once you know, you go, oh, you motherfucker. So like someone could pull the wool over your eyes about that. They could just easily do it with any kind of science or rocket travel or anything.
See, that's what really got me interested in science.
What was the most spectacular sight on the Apollo flight?
You know, every sight in space is spectacular. I mean, you just can never look out the window without being amazed at what you see. And I hope that technology will allow more and more people to go and see those sights and see our planet. It's a beautiful place, particularly when you see it from a distance. It's a magnificent sight. But the most beautiful sight, as we were approaching the moon, and I'd say maybe we're 7,000 miles out, pretty close, we flew into the moon's shadow, which means that from our point of view, the moon was eclipsing the sun. So we would see the dark gray moon, and behind it, the corona of the sun coming out all around. It was a lovely sight. And now we were close enough that the moon wasn't a disk as we see it from here on Earth. It looks pretty flat to us from here. But it was clearly three-dimensional, a ball, and it was covered with ridges and craters and valleys and hills and all manner of, And that was decidedly, it was in the dark, but it was being illuminated by the light of Earth. Now, because Earth is, as you know, 16 times bigger in area than the moon, and it's also more reflective. So consequently, it's substantial. Earthlight is substantially brighter than moonlight at the same distance. And because of the oceans, that light is decidedly blue. Light is blue. So we were looking at this three-dimensional ball with all these valleys and ridges and craters and things. We're falling. It was illuminated by blue Earth light, and we were flying toward it faster and falling faster and getting closer and getting faster. I thought it was the most beautiful sight I'd ever seen.
Clinging on.
Now, you can't sit in any kind of a machine and accelerate 7,000 or 8,000 miles an hour without you suspecting that something's going on. But you see, it was at night. We were on the night side of the Earth over Africa, and we couldn't see, and you just couldn't get an appreciation of what it was that was happening. But as we came out into daylight over Indonesia, we could see, and it was spectacular. We were ascending from the Earth at a rate of, something like going outward at 5,000 miles an hour or 7,000 miles an hour, something like that. But from our point of view, we just seemed like we were motionless, and the Earth was sinking away from us. And we could see more and more of the horizon, the Pacific out there, the Gulf, the Indian Ocean, Malaysia. All of a sudden, we could see the whole sphere, a great, gigantic blue ball covered with a white lace of clouds. And it was just sinking further and further away, sort of into that inky black sky. Well, I said to myself, boy, this time you might have just gone and done it.
In regards to the computers, we were chatting about this. On the actual Apollo, the landing module, the whole process, how powerful a computer did you have? How, in today's terminology, how powerful would you say it was?
Well, it was not as good as a laptop, but it was probably a little better than a handheld. It actually had, some of you that are computer nerds,
he's a pilot. He's not a nerd.
You got to have gigs and that kind of stuff, and we didn't have gigs or even megs. The Apollo computer had 32K of fixed memory and 2K of erasable. That was it. No screen, no sound, no icons, no nothing. And the keyboard just had, it had 0 through 10, read, clear, and enter. I think it might have been 1 or 2 more keys. We had no graphics, no screen, no. On its best days, it couldn't get to 1 megahertz. So it was slow and weak, but it got its there.
Hey, baby. Hey, back. Yeah. One last one from me. I got a question for me. There's one thing I want to know. There's one thing I want to know since the day you agreed to come. And as I mentioned to you, we live on a house, top of a hill, and we get so many great views of the sky at night. And here's the question that's just been, every time I go home and I see the moon, this is the question I've been wanting to ask you. It's a crystal clear November evening, little nip in the air. It's just as clear as can be. And you're driving home, and you get out of your car, and you look up. Like that. And you see this image like this, okay? What comes to your mind? What jumps to your mind?
Girls. Let me back up a little bit to the Apollo goal, which you all talked about earlier in the day and so on. The nice thing about that goal was that it was so simple and understandable. Send a man to the moon, return him safely to Earth by the end of the decade. I mean, everything you needed to know was there. And I think it's a great advantage when goals can be stated in such a way that they're not ambiguous and you know exactly what it is you're trying to do. And that was a model for me. I've never been as good at doing that for myself as Jack Kennedy did for our program. But the important thing to me, and I think probably to many here, is that you want to make a mark. You'd like to leave the world a little better than when you came. That's my goal.
Okay, Houston, as I stand out here in the wonders of the unknown at Hadley, I realize there's a fundamental truth to our nature. Man must explore.
One of the things you got to stop and do, make sure, is to have fun too, because you're only probably going to come this way once.
I was strolling on the moon one day in a merry, merry month of December. Now, May, when much to my surprise, a pair of bunny eyes. Do-do-do-do-do. Oh, is this a neat way to travel? Isn't it great? Dum-da-dum-dum-dum. 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 I like to skip along. But me, boy, skip. Or whatever you call it. I can't get my left leg in front of me. Dum-da-dum-dum-dum. Dum-da-dum-dum-dum.
It was almost dangerous. And you lose sight of the fact that it's a vacuum out there, and if you spring a leak next to it, you're going to be dead.
Uh-oh. Nice soft Navy landing. Yahoo! Oh. Ah. Boy, do I like to run up here. I feel like Bugs Bunny. That's neat. And here comes the Boxy twin. You're pretty agile there, Twinkle Toes. I'm going out for the ballet when I get back. You learn another line of work up here. And while you're bouncing around there, you might keep an eye out for a nearby crater. All right. I've been on my knees twice to get there. John? Yes, sir. You are black from the knees down. No way to avoid it. That's why I'm glad the pressure suit bends. John, you are filthy. I tell you, there's a pot called the Kill Blast. Hey, here's a rock I'll be glad to see in Houston. Man, Tony, you don't know how much fun this has been. We concur, John.
Mr. Armstrong, I do realize that when you were on the moon, you had very little time for gazing upwards. But could you tell us something about what the sky actually looks like from the moon, the sun, the earth, the stars, if any, and so on?
The sky is a deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon. The Earth is the only visible object other than the sun that can be seen, although there have been some reports of seeing planets. I myself did not see planets from the surface, but I suspect they might be visible. The Earth is quite beautiful from space and from the moon. It looks quite small and quite remote, but it's very blue and covered with white lace and of the clouds, and the continents are clearly seen, although they have very little color from that distance.
What about the sun? Could you see any trace of the corona?
No, the glare from the sun on the helmet visor was too difficult to pick out the corona. The only time we could see the corona was during an eclipse of the sun from the moon. That is, when we were flying through the moon's shadow and could observe the solar corona peeking out from behind the moon.
Looking at the photographs that you brought back, the colored photographs of the moon's surface, it seems that the color of the surface actually varies according to the angle from which you see it. Is this so? Does it do this?
Yes, it certainly does. It's a characteristic that we observe first while traveling around the moon in orbit. You could see that at the terminator, at the boundary between the black part of the moon and the lighted part of the moon, it was as if you were looking at a television set with the contrast turned to full contrast, very black and very white. As you moved further into the light, there were more and more shades of gray. But as you moved further, such the sun was higher above the horizon, you actually start to see the tans and browns appear, although at a very low level. Similarly, on the surface of the moon, the same characteristic is evident. You can see browns if the sun is high enough. Apollo 12, for example, landed while the sun was only 5 degrees above the horizon. So when they arrived, they saw no browns or tans anywhere, only fairly high contrast grays.
But you did?
But, yes, I did. The sun was at 11 degrees. And Apollo 12 did also the next day when they arose from their sleeping period and the sun was higher. Of course, then the browns were observable to them.
When you were actually walking about on the moon's surface and kicking about a certain amount of dust, did you notice any local color? And also, were you at all subconsciously worried about the possibility of unsafe areas?
Well, the color is a puzzling phenomenon on the moon, aside from the characteristics that I've already mentioned. You generally have the impression of being on a desert-like surface with rather light-colored hues. Yet when you look at the material at close range, as if in your hand, you find it's a charcoal gray, in fact, and we were never able to find anything that were very different from that color. I suspect that as we get more and more samples with future flights, we will see that there is, in fact, some color, but the optical properties on the moon are most peculiar.
When you were actually walking about, did you have any difficulty in distance judging? Because I think I heard you say once that far things looked quite near.
Yes, we had some difficulties in perception of distance. For example, our television camera we judged to be from the cockpit of the lunar module only about 50 to 60 feet away, yet we knew that we had pulled it out to the full extension of a 100-foot cable. Similarly, we had difficulty guessing how far the hills out on the horizon might be. The peculiar phenomena is the closeness of the horizon due to the greater curvature of the moon than we have here on Earth, of course 4 times greater, and the fact that it is an irregular surface with crater rims overlying other crater rims.
you can't see the real horizon. You're seeing hills that are somewhat closer to you. There was a large crater which we overflew during our final approach, which had hills of the order of 100 feet in height, and we were only 1,100 feet west of that hill, and we couldn't see a 100-foot high hill from 1,100 to 1,200 feet away.
Did you notice any obvious difference between the far side and the near side as you went round it? I mean, apart from the obvious differences in topography?
No observable differences in color, but then the sun's angle was always somewhat different over there, so it would be difficult to make a general correlation. I would say the topography is the striking change. Of course, as all your viewers know, there are no seas on the far side of the moon, and it's all highlands and high mountains, big craters. So it's strikingly different from the.
There's just one more thing I'd like to ask you. You're one of the very, very few people, I think, whose opinion on this is really worth having. In fact, there are only 4 of you. Do you think, from your knowledge of the moon, having been there, that it is going to be possible in the foreseeable future to set up scientific bases there on anything like a large scale?
Oh, I'm quite certain that we'll have such bases in our lifetime. Somewhat like the Antarctic stations and similar scientific outposts, continually manned. Although certainly there's the problem of the environment, the vacuum, and the high and low temperatures of day and night. Still in all, in many ways, it's more hospitable than Antarctica might be. There are no storms, no snow, no high winds, no unpredictable weather phenomena that we're yet aware of, and the gravity is a very pleasant kind of place to work in, better than here on Earth, and I think it would be quite a pleasant place to do scientific work, and quite practical.
Mr. Armstrong, thank you very much, and again, let me say what a tremendous honor and privilege it's been to have you with us.
Thank you.
What does a day like this mean to you, one of the few people who've gotten to walk on the moon?
Well, what it means is actually far more interviews than usual on any given day, because you folks are, I mean, NASA has said, okay, 40th anniversary, pretty good deal. And everybody wants to, and the press has been featuring it and all over. So yeah, a lot of interviews. And who invited you up? You want to be a part of this too? George, okay, let me pet you and you jump down. You want to call her over, please? Go on. Give her a cookie. Oh, that's okay. She's under there now.
When you take me back to 40 years ago today, what was going through your mind when you...
Well, I was in mission control. As an observer, I didn't have a job in mission control at that point. We were already preparing for our mission. But mission control, watching the excitement going on, and Charlie Duke was Capcom during that point, and Bruce McCandless was surface Capcom. So getting to watch their activity and get out, landing, or get out on the surface and do their job and then get back in. And
when they hit the surface and made a clean landing.
Yeah.
And,
well, that was the first. That was the first big thing. Yeah, that's great. They did it. They safely landed. That was always the big F. Finding a landing site that was safe to land on, because we didn't know, and we had photographs, of course, from unmanned orbiters that took pictures. But it turns out they didn't help us a lot when it came to finding your way around the surface of the moon. But the fact of landing and landing safely, that was a big step. And then able to get out and walk on it, that was the next big step. And
were you thinking, boy, in a few years I'm going to be doing that same thing?
Well, we were already in the process, that's right. And see, each mission built upon the success of the past mission. And we, it's called expanded the envelope. You go a little bit further and do a little bit more. So I was back up on Apollo 10, which was dress rehearsal for the lunar landing. And then the drill was that once you served as backup, 3 flights later, you were scheduled for a prime crew. So Apollo 10 meant I should be on Apollo 13, which we were assigned to Apollo 13. But Gordon Cooper was with me as commander on Apollo 10, backup. And he retired, so Alan Shepard was coming on the crew as the commander for Apollo 13. But he had been grounded with Meniere's syndrome, an inner ear problem, for a while, but had that fixed. And was assigned to Apollo 13 by headquarters in Houston. But headquarters in Washington overruled and said, Alan, you haven't been training, so why don't we shift crews? You take 14, Jim Lovell and his crew take 13 to give a little more training time to you. We didn't want to do that, but we did it. The boss said so. But so as it turns out, they got a bad machine, we got a good machine. And so the sequence of events, Apollo 10 was dress rehearsal. Apollo 11 made the landing to show we could do it, grab a handful of samples. Apollo 12 was to land and show we could land precisely where we wanted to. They landed near a surveyor spacecraft, earlier craft. Then Apollo 13, which we took over their mission as 14, the job was to begin science on the moon. So we had the first wheeled vehicle, which was a little golf cart-like device we pulled, carried our equipment, and had the longest on-foot traverse on the moon. And then the guys after us had longer stays, but they had a little lunar rover to get around in. So
what was it like stepping foot on the moon?
Well, that was a wonderful part. Was just, I mean, what more can an explorer want? But to go to a place where humans have never been, look around, take pictures, grab samples, do what you're supposed to do, and come back and tell the people. And that's what we did.
And what was it like? I mean, describe the atmosphere. Was it quiet, deathly quiet?
Well, of course, it's deathly quiet because there is no atmosphere. There's no sound that can be transmitted through the atmosphere. And
was it eerie? What was going through? I mean, as you
well,
the first time.
You have to recognize we were scheduled at about 120% of human capacity in case something broke, some piece of equipment broke, which we expected it to, but it didn't. So that meant we had to work to about 120% of capacity. So it was go, go, go. The clock, Houston was whispering in our ear, you're 2 minutes behind, you're 5 minutes behind. So we were going strong. However, the sensation, that's mostly what people want to know. I tell young children when they ask about it, I say, well, particularly if they lived in the north, Mama sent you out with an overcoat on or a snowsuit on, but imagine it's 2 snowsuits on, so it's stiff and hard to move around. But the reduced gravity is like walking on a trampoline. So you're out on the surface with 2 snowsuits and a trampoline, and that's what it feels like to be on the surface of the moon. But it's a dusty surface, and dirt is kicking up and clinging to your suit. So we found out very quickly we had to be very tidy and brush everything off as best we could before getting back into the spacecraft and not contaminating it any more than we had to.
What was the view like?
The view is like, well, and let's put it in this case of what's the nearest thing on Earth, and that would be a desert, the sand dunes. The undulations of the craters are very much like sand dunes, but it's a gray, depending upon what angle you're looking. Cross sun, it'll look tan or brown. Up, down sun, it's gray. And that's because on the front side where we landed, the surface is mostly volcanic rock that's come out of the inside of the moon and flowed in basalt, lava flows, flowed into the craters. But over the last several billion years, meteor impacts have pummeled it, broken it up into fine talcum powder like dust. So where we landed on the front side is, and in craters filled up with lava rock and pummeled into very fine dust. That's what you're dealing with. And that's why the big foot pads, we weren't sure that you wouldn't sink into the dust. We didn't, as it turns out. It's only footprints about that deep. But the so-called regolith, or the very fine powder-like substance, is several meters deep, having been filled up by lava flow and then pummeled into very fine talcum powder, like powder.
Looking back at Earth.
Well, in our particular mission, you couldn't look back at Earth without getting a hold, since we were right on the equator, right in the center of the moon virtually. We couldn't look back without holding onto the spacecraft and leaning way back to get directly overhead, because Earth was directly overhead. But that's wow, a wow experience to see Earth. But you see, we could see it much better once we got back into orbit. We could look from in the spacecraft.
What does it look like? I mean,
well, you've seen the pictures.
Right.
At the beginning
Is
of...
it almost surreal, though, knowing that
It's almost surreal, yeah. It's seeing Earth as it really is. Fred Hoyle, the great British astronomer, pointed out at the beginning of the space program, if we ever get pictures of Earth from space, life will never be the same again. And because humans have always asked the question, looking into the heavens, what's this all about? Who are we? How do we get here? What's the real deal? And when you see all this from Earth, from space, and see it in a different perspective, I call it the big picture effect. It's like seeing things in a humongously larger scale size. And it's just, it's overwhelming. And so we have to, as scientists, re-ask that question, that ancient question. Who are we? How do we get here? Where are we going? What's this really all about? What is our relationship to the cosmos? And fortunately, due to the Hubble pictures that we've brought back from space, in the last 20 years, we're seeing pictures of the universe on a scale size that no humans have ever seen before. So it's causing us to look in awe and amazement at the immensity of the universe that we've never known before.
I want to take you back to, again, standing in mission control.
Okay.
When they actually landed. Obviously, you guys have been planning for this because you're getting ready for your own mission to the moon. But to actually have accomplished it, I mean, no one knew what was going to happen.
True. But here, remember, we were all test pilots. We've been military pilots. We were used to expending the envelope and doing hazardous missions. So here they had made the first step successfully. We didn't have to repeat that. We could now go a step further. And in each case, in the case of each mission, we expanded what we could do a little bit more. We could take the next step. We built upon the success of the previous guys.
You glad you went to the moon?
Of course. I mean, what more can an explorer ask? To do what others, to go where people have not been and bring back the story.
And I just can't, it's impossible to grasp unless obviously you've been there, I suppose, but describe one more time just what it was like when you stepped off, and without Houston whispering in your ear, but just...
Well, you step off, the first thing, you see the pictures, we had not compressed the landing strut very much. We landed very gently, and the landing gear had a compression strut in it, a shock absorber, as it were, so that if we landed hard, it would compress and kind of ease us down. But we landed gently, so that last step from the bottom of the ladder was over 3 feet. We had to jump off the bottom of the ladder and kind of float down to the surface. The first thing we did, each one of us had to do, was assure ourselves we knew how to get back in, which meant jump off the foot pad and pull with your hands to get your foot on the first rung of the ladder to come back up. We'd already knew we were going to have to do that because that was what we practiced back on Earth. So that was the first thing. You jump down, you pull yourself, jump back up to make sure you could do it. Then you step off and you kind of get your balance and say, okay, am I going to stay balanced here in this lunar gravity, because 1/6 gravity it's a little different, and you have this cumbersome life support system on your back that if you lean too far back, you're likely to fall over. So learning to navigate and walk and get your balance is the first thing you do. And then you can set out to do your assigned tasks. And the first task in this case was to set up the flag, take pictures setting up the flag, and getting all the equipment out.
How cool was the flag?
Huh?
How cool was it doing that?
Oh, that was fun. Found a little spot out in front of the spacecraft, and it was in two sections. Drove the bottom section in, then you could put the flag into it. And of course it had because there's no air on the moon to wave the flag, it has a aluminum rod in to hold it out straight, so it looks like it's waving in the wind. You could see it. So that was the first step we all did. Then you went ahead, our next job was to set up a science station.
Before you set up that station, did you get a chance to just stop for 30 seconds and just take in the fact that you're standing?
No, you might 2 seconds might be closer, because as I said, the clock was ticking, and once you had your balance and you knew you could navigate, next thing you did was get on with the work and get everything unloaded, because the camera was running. Set up the camera. Houston was on our backs to keep going, so it was go to work, and you'd have time, if we had a little time at the end of the day, which we did, have a little time at the end of the day, 20 or 30 seconds to look around and admire the scenery. You could do that, but we actually didn't have much time to do that. You did it while on the go.
And finally, how important do you think this day 40 years ago was in American history?
Well, it was a beginning, and it's unfortunate that we haven't continued. Some of my colleagues want to go on to Mars from here. I personally feel that we need to go back to the moon. We need to gain more experience in planetary exploration. We did not really complete the work on the moon. We only put 6 missions there for a few hours each one. We need to set up a station, kind of like Antarctica. We have a weathering over a weather station in Antarctica to learn to work in that hostile environment. Well, the moon is an even more hostile environment. And before we go a year's travel to the Mars to start doing something there, I personally feel we needed to rebuild our experience base. We need to rebuild our capability, because most of us who did that were 40 years ago. We're old men now. And you young folks that are coming along need to build up the experience of planetary exploration before we go to Mars. Now, we will go to Mars in due course, I believe, if we don't blow ourselves up with some of our stupidities in the process. And in the long run, remember, we have to be off this planet before our sun burns out, which it will in another couple of billion years. So if our species is to survive, we have to be universal species. We have to be a species of the universe. So we've got to get out of here. And going to the moon and going to Mars and exploring our own solar system is the first step in doing that.
Scientists classify Earth as a terrestrial or rocky planet, along with Mercury, Venus, and Mars. Our next guest is an astronomer and an astrophysicist, and he takes us on a tour of these 4 planets that are closest to the Sun to show us how they demonstrate the magnificent work of our Creator. Coming up next on Origins, the terrestrial planets with Dr. Jason Lisle. Hello, my friends, and welcome to Origins. My name's Don Chapman, and it's my privilege to be your host. During this program, we showcase interesting guests who present evidence from science along with other important facts validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. Jason Lisle, has a PhD in astrophysics from the University of Colorado and is the author of Taking Back Astronomy, The Heavens Declare Creation. He was instrumental in the development of the planetarium at the Creation Museum in Kentucky, and he currently works as Director for Research at the Institute for Creation Research in Dallas, Texas. Dr. Lyle, we are so delighted to have you here with us.
Thanks for having me on.
It's wonderful. You're one of my favorite guests, and today what are we going to do?
Thought we'd take a look at the planets of the solar system, and particularly the inner planets, and maybe we'll get to Jupiter, time permitting, but we'll look at those.
How many are in
ones.
the inner planets?
There are 4 inner planets, and they're called terrestrial, which means Earth-like, basically.
Okay.
Because they're similar in some aspects to the Earth.
So this is Earth and its 3 closest neighbors.
That's right, exactly.
Wonderful.
And in increasing order from the Sun, they're Mercury, Venus, Earth, and Mars. And so I thought we'd just take a look at these, and of course I'll have this computer simulation software here that will allow us to look at these in detail.
What a neat thing this software is. It changes the way we look at everything.
It really does, and it's very accurate too. It's what I appreciate about the folks that wrote this software. Here we have Mercury, for example, and you can see that Mercury basically looks a lot like the Moon. It's a cratered world. It has no substantial atmosphere, maybe a real thin, but nothing substantial. And that's why you can see the surface is very cratered. It's got all these impact craters. There's nothing to stop it. Of course, objects that would impact Earth tend to burn up in our atmosphere. And so we have that nice protective atmosphere.
The atmosphere protects us.
That's right, it does. Mercury doesn't have that. And so that would be a little bit dangerous if you were there. Another issue would be the heat. Mercury is 3 times closer to the Sun than we are. It's about 1/3 the size and 3 times closer to the Sun. And that means if you were on the day side of Mercury, the surface temperature would be close to 800 degrees Fahrenheit.
800 degrees.
Yeah, so bring your sunscreen. Yeah.
Wow.
And then on the night side, it drops to, a couple hundred degrees below 0. So it gets very, very cold on the night side. People don't realize that.
And it's part of that because the atmosphere buffers our temperature.
That's right.
It has no buffer.
That's right. There's actually two reasons for it. One of them is the atmosphere.
Okay.
There's no atmosphere to even out the temperatures. And the other reason is it's a very slow rotator.
Oh.
Yeah, Mercury rotates very, very slowly.
Like a
I think
rotisserie.
Yeah. Very slowly. So one side really gets baked. And it takes something like, I think it's 58 days for it to just for it to rotate.
It is slow.
Earth days, yeah. So it's very, very slow rotator. And for that reason, the day side just bakes and the night side just freezes. And of course, it is interesting that if you landed on the night side of Mercury, of course, you could have a spacesuit that would protect you from the cold temperatures potentially. But if you landed on the night side of Mercury, if you crash landed, okay, you can't get off. You're in your spacesuit. You're in your spacesuit. As long as you run west, you could actually keep ahead of the sunrise. It would be possible to run fast enough.
The rotation's so slow
that's right. You
that
could outrun it.
A jogger could stay out of the heat.
That's right.
Till he got tired.
You can't stop though. You can't stop because once you stop, the sunrise just catches up and then you're gone. So it's one of those little interesting factoids.
How
about
long
Mercury.
can you tread water? How long can you jog?
Exactly.
That's it. Yeah.
Exactly. So it's a neat little world. It's again, it's smaller than the Earth, about 1/3 the size of the Earth, and you can see it's just pockmarked with craters. And for a long time, we didn't know what one side of Mercury looked like because we sent a spacecraft there in the 70s, and it went past Mercury and mapped one side, and then it was in such an orbit that every time Mercury orbited twice, it would come back around and it mapped the same, but it got the same side because of the way Mercury rotates.
Yeah.
Mercury rotates, let's see, it's 3 times every time it orbits the Sun twice, and so they got the same side every time, interestingly. Another interesting thing about Mercury is it has a slight magnetic field. And that's interesting. Of course, the Earth has a magnetic field that causes your compass to point north, and that's caused by electrical currents in Earth's core. Mercury has that too. Mercury's is weaker than Earth's, but it's there. And that's surprising from a secular perspective because magnetic fields decay with time. They naturally run down as that electricity encounters resistance. The magnetic field decays. And we actually have good evidence that Mercury's magnetic field is decaying just like we'd expect because we sent another spacecraft there more recently. The Messenger spacecraft flew past Mercury, measured the magnetic field, and there are indications that it seems to have dropped since the 70s. So we've actually been able to measure.
Rapidly.
Yeah. And we'd expect that based on known physics. But the interesting thing is that's only compatible with a biblical worldview.
Oh,
because you see, because the magnetic field decays so rapidly that in 6,000 years, it would be about this amount. But if it's billions of years old, it would be gone by now. It should have decayed a long time ago. And so
that's fascinating. The rate of decay is a constant.
It's an exponential decay, but we think the exponent is constant based on our understanding of physics. And so that means if you run it back in time, the magnetic field would have been outrageous if you push it back beyond 1 million years or something like that.
So it's an argument for a young Earth.
It is, or a young solar system even.
Yes. Yeah. I mean, young solar system. Sure. Excuse me.
So it's an interesting little world. Again, we can see it rotating here as I speed up time, but you can see it rotates very slowly, and it's actually orbiting the sun significantly as it rotates. And let me change the orientation here a little bit so we can see that.
You would almost think the tremendous heat that one day it would just kind of burn up.
Yeah, although it doesn't have flammable type of elements that it's made of. It's mostly rock, and rock can withstand a lot of
heat.
temperatures. But that's one reason why it doesn't have much of an atmosphere. Any atmosphere would tend to boil away. So that's Mercury. And it's an interesting little planet. It's hard to see because it's always very close to the sun. And people might have seen Mercury without knowing it. It would be just after sunset or just before sunrise. It will appear as a little star, depending on where it's at in its orbit. And it's a little hard to see. So let's go to the next planet, Venus. Venus has been called Earth's twin because it's about the same size as the Earth. And that's about where the similarity ends. It's other than it's solid. Okay, so it's got a solid mass on its surface. But that's kind of what Venus looks like. You can see it there from space. Venus is very easy to see. Very easy to see from Earth. In fact, it's the third brightest object in our sky. You got the sun, you got the moon, and Venus.
And you got Venus.
Yeah, in terms of the naturally occurring objects that are regular objects. And you can often see it in the evening sky as a very bright star in the evening sky or in the morning sky, depending on what part of its orbit it's in. So that really people look at it, man, that's a bright star. It's Venus. It's Venus. And it's one of the stars that's mentioned in Scripture as the morning star.
Oh, it's the morning star, the bright and morning star.
That's right. That's right. That's Venus. So it's a lovely planet. It's beautiful to look at, but you probably wouldn't want to go there either.
Kind of looks like an egg.
Yeah, it kind of does a little bit. It's got that kind of yellowish color, and that's because that's clouds that you're seeing. Okay. Venus is permanently...
It has an atmosphere.
It has a very thick atmosphere, much thicker than Earth's. 1,000 times something like Earth. It's very, very thick. And those clouds that you see there, they permanently enshroud Venus. And so you would never see the sun on Venus.
Wow.
It would be permanently overcast. And growing up in Ohio, it was kind of like an Ohio winter, really.
What's the temperature?
The temperature, interestingly, is actually hotter than Mercury. The temperature is 900 degrees Fahrenheit.
And why is that?
And why is that?
Because it's further away.
You think it'd be less,
from the sun.
but it's because of a greenhouse effect. That atmosphere traps in the heat
Cooks it,
and basically cooks the surface. Yeah. And we've landed, actually the Russians landed some spacecraft on the surface of Venus, and they lasted for a little while. They were able to take a couple pictures before they gave out, because it's hard to make something that can survive in 900 degrees Fahrenheit temperatures. But it's really interesting. In fact, the atmosphere is very, very thick. It's so thick it actually bends light significantly. And that would have the effect, it would make things look distorted. If you were standing on the surface of Venus, instead of the world going down because it's a sphere, it would seem like it's going up. It would feel like you were standing in a large bowl because the surface would seem to go up. Isn't that strange? Because of the way the light bends.
Yeah.
But that thick atmosphere is what really makes Venus kind of interesting and unique in terms of the inner planets. Now today we can penetrate that atmosphere and with radar, and we know that the surface of Venus looks like this.
Oh.
So it's a really interesting surface, and we can watch and see how Venus rotates with time. Venus actually rotates backwards and very slowly. Its day is actually longer than its year, interestingly. And let's see if we can get this, make sure we're turning the right way here. There we go. Let me spin it around here. Yeah, that's right, that's right. So there it is rotating backwards. And you can see it's orbiting the sun the same direction as the other planets, but its rotation is the opposite. And so the day actually being longer than the year in terms of its rotation.
Do we know what causes that? What would make one planet rotate one way and another way?
There's only one explanation as far as I know, and that's God is creative, and He's given these planets different spins. I don't think there's any secular explanation for that.
Explanation, just God made it that way.
In fact, in the secular view, the planets really ought to be aligned. They ought to be the same and rotating at about the same speed in the same direction. And that's the expectation of the secular model, and few of them do, really. I mean, a lot of them are different, and usually they invoke a giant impact to say, well, something hit it and changed the rotation. But Venus is almost exactly upright. It's just backwards. It's just rotating backwards, and so that's contrary to what you'd expect, really, in the secular model.
Continues to point to a designer creator who just said, because I'm an artist also, I'll just make this one go this way.
That's right. That's right.
Isn't that awesome?
I mean, the solar system, some things need to be a certain way for the solar system to work. And so it's probably a design feature that the planets all orbit in the same direction so that there are no collisions, for example. And so that makes sense. But they can rotate different directions, and Venus does that. Now, again, we mentioned the surface temperature is not very pleasant, and also those clouds that cover Venus are sulfuric acid type compounds. So there's just lots of wonderful ways to die on Venus. It's not a place you'd want to visit, really. Yeah. It has no moons. And it has no liquid water or anything like that. Of course, it couldn't, water couldn't exist in a liquid state with that kind of temperature. So it's Earth's twin in name only and in size only. It really is about the same size as the Earth. But that's where the similarity ends. Other than that, it's a toxic world. And some people say, well, why would God create, with thick, a poisonous atmosphere like that? Well, we're not supposed to go there, right? I mean, Venus is designed to do what it does. And those clouds that would kill you if you were there make Venus very reflective, and they make it one of the most beautiful objects in our nighttime sky. Yeah. So it really is stunning.
The morning star.
Yeah. Now the next planet out is Earth.
I've heard of that one.
I've heard of that one too. And all the best restaurants are on this planet right here.
Is that right?
And everyone you know or ever will know is on this little planet right here. But Earth has a number of interesting features that are unique just in terms of a planet because it is designed for life. And so of course it has liquid water on its surface, which we think is necessary for any kind of life to exist. And so Earth's covered with liquid water. That's one of those ingredients for life. Earth also has plate tectonics. As far as we know, it's the only planet that has plate tectonics.
Is that right?
Yeah. And we think that that's also a design feature because we think the mechanism that God used to flood the world and then to establish the world again after the flood of Noah. We think actually the continents were probably together before the flood year and then pushed apart. And so God flooded the only planet that really could be flooded, and in a way that he designed the planet to be able to do that. So it's kind of interesting that it's designed with just that feature in mind.
It seems to me the evolutionists are desperate to find water somewhere else.
Yeah.
Because water really is linked to life, isn't it?
It really is. And they would say, well, where you find water, hey, life probably evolved. Well, no. You can have water out in space. And the water molecule is actually pretty common in space, although Earth's the only place we know of where it's abundant in its liquid state. But it wouldn't surprise me if they found liquid water somewhere else in the universe. It's a big universe.
And it really wouldn't prove anything.
No, it wouldn't. It wouldn't. And I would not expect really to find life out there. The Earth is specially designed for life.
Right.
In fact, the moon actually stirs up tides on Earth's oceans, keeps the oceans from stagnating. Yeah, and so it has that cleansing effect. And so it really is designed for life. It has those special features. Now our next planet out is Mars. I'm not going to spend a lot of time on Earth since we live there. I figure people probably know that one pretty well. Mars is probably the most Earth-like planet in terms of if you wanted to go there on vacation. Mars would probably be the one to pick. You'd at least have a chance of surviving if you brought your spacesuit and enough food and water and so on, because Mars is similar. It's not similar in size, about half the size of the Earth. But the temperature, it's a little too cold, but it's not astronomically cold. It's just a bit chilly there.
What does a bit chilly mean? Put some numbers on it.
Well, it could get above freezing at some times.
Is that
in the
right?
Summer.
Okay.
Yeah, it could actually get above freezing. And it has polar ice caps, and you can see there the northern polar ice cap. And it's got one on the south as well. And they changed like Earth's polar caps grow in the winter and then they shrink in the summer on each respective hemispheres. Mars does do that too, just like that. Mars has seasons. It's tilted about the same as the Earth.
Yeah.
So it would have seasons about the same as the Earth.
Seasons.
Mm-hmm. The year is about twice as long as the Earth's. So, but other than that, you're a little bit further away from the sun. The sun would be a little darker, a little smaller in your sky. But the rotation rate's similar to Earth, 24.5-hour rotation, which is kind of neat because you could get up a half an hour later every day and it'd never catch up with you. So it's kind of neat. It's just got that little extra half an hour that you could sleep in every day. So that's kind of a neat feature.
It sure has been the place that's captured the fantasies of the science fiction world.
Yeah. And that's because it is most Earth-like. Yeah. It has volcanoes on its surface, mountains. In fact, you can see, let me rotate it around here, you can see some of these volcanoes. Some of these features you can see from Earth with a large telescope, in fact, but especially these volcanoes here. You can see these large, you see those right there, those large, looks like big pimples. Well, those are actually large volcanoes. In fact, this one over here to the left is Olympus Mons. It's 3 times taller than Mount Everest.
Are these active volcanoes?
They're not. They're thought to be extinct, but it might be that they're just dormant. Some creationists think that these could erupt at some point in the future. It's possible.
And if they erupted, would it affect us in any way?
No, it would not. Okay. No, but it would be a spectacular...
It'd be something to watch.
Yeah, it would be something that would be indicative of biblical creation, because the secularists think Mars is billions of years old and therefore dead and should have no volcanic activity. Well, we think it might still have some.
Wow.
We think it's still possible. There are canyons on Mars. Here's a massive canyon. See that big, looks like a scar along the surface?
Right.
That's the Valles Marineris Canyon. It's much bigger than the Grand Canyon of the United States. In fact, that's about as big as the United States is across.
Wow.
Just to give you a feeling for that.
The whole way across
the
country.
So it's really amazing. Yeah. So it's a wonderful little planet. Now, again, Not quite right for life, because the atmosphere is carbon dioxide and very thin. You couldn't breathe on Mars. You'd have to bring a little bit of Earth with you. You'd have to bring your spacesuit, a little bit of air. No liquid water on the surface as far as we know. The conditions aren't quite right to support liquid water under most circumstances, but there's evidence that Mars once had liquid water on its surface, dried riverbeds and such. So it really is an amazing little world, and it reminds us that God is creative in the way that He creates these different planets.
He sure is. We're going to come back to that in just a minute, but we have to take a break. We have an incredible God. He's an engineer, He's an artist, and He's a creator. And we're going to talk about it when we get back. Don't you go away. We are back with Dr. Jason Lisle. And Jason, I've always wanted to say this, so I'm going to get to say this. When we left, we were on Mars.
That's right.
So take us back.
Okay. We're talking about Mars and how it is Earth-like in some ways.
Right.
The polar ice caps, they're actually made of carbon dioxide, frozen dry ice.
So it's
some
not
water
ice like
right.
our ice. It's more like dry ice.
There's some water ice too, but it's mostly carbon dioxide, frozen carbon dioxide, dry ice. And water would have the same effect on Mars that carbon dioxide does on Earth. Dry ice, it doesn't go to a liquid state, it goes directly to vapor. Water would do that on Mars because there's insufficient atmospheric pressure to keep it liquid.
Oh,
so yeah,
that's
so it's kind of interesting.
Yeah.
A little bit of an atmosphere, so you'd have a blue sky, interestingly, sometimes, and sometimes the wind will kick up the dust and you'll get a pink sky. And so it depends on the time of day and the local conditions there. But otherwise, it's kind of similar to Earth in that respect.
We would have that if we had a dust bowl.
Yeah, you have something like that.
During the,
absolutely.
Yeah.
Mars has 2 moons, interestingly, and I wanted to show you these because they're kind of interesting to me. They're very different from Earth's moon. And we'll go to Deimos first. That's number 2. So Phobos and Deimos are the names of Mars's 2 moons. And the names mean fear and terror. And that's because Mars is associated with the god of war, and fear and terror go along with war. So when these were discovered, they were named after that. And there's Deimos, and you can see it's a weird-looking little moon, isn't it? And if we speed up time, you can watch it rotate around like that. And you can see it's one of the first things that surprises people is, wait a minute, it's not round. It's not a sphere.
Right.
And smaller moons tend to not be round. This moon is only it's less than 10 miles across.
Okay.
It's basically a big boulder in space. That's what it is. And it orbits around Mars. And it takes something like a day for it to orbit Mars, something like that, around 30 hours, I believe. And it just looks kind of like a big potato there floating in space. Really interesting. And so that's Deimos, the outermost of Mars's 2 moons, the outer of the 2. Now the inner one, Phobos, let's go to that one next. If we zoom out here a little bit. And there's Phobos on the other side. You can see these moons in a small telescope if you really know what you're doing, if you really know how to look for them. They're actually pretty bright, but Mars is 200,000 times brighter. And so it's a contrast issue. You have to in order to see these well, you have to kind of get Mars just off to the side of the telescope so the glare doesn't get in the way. And I've seen both Phobos and Deimos in a small telescope, little specks. And again, Phobos is just a little bigger than Deimos. It's only about 10 miles across. And you can see there, it's got a huge crater on one side of it. Looks like something hit it really hard. So really fascinating.
Now, our moon, we can see in God's creation plan that it has function. It creates the tides, which clean the ocean and things.
Right.
Is there any function known to these moons?
We don't know what they're for, what they do, other than it's, I think, an example of God's creativity. You know, Mars has 2 moons. Their gravity's not nearly sufficient to stir up any kind of tides. Of course, Mars doesn't have oceans anyway.
Yeah.
But their gravity would be insufficient to stir up tides. So you see, Mars doesn't have those design features that are right for life on Mars, because it's not designed for life. It really isn't. But nonetheless, they're interesting, and it gives us little examples of interesting physics. For example, if you were on the surface of Phobos, the gravity there is so weak, you could pick up a rock and throw it into orbit.
Oh, my.
Go around, and you better duck because it come back
around and hit you in the head.
or you could play catch with yourself. You could throw it that way and then catch it like that.
You keep practicing.
Yeah.
Make for an interesting baseball game.
And it orbits very close to Mars, so you can actually see. You can actually imagine looking up at the night sky and seeing Mars like that just up above you. I mean, it would be just spectacular.
Yeah.
So it's a fun little moon. It's a fun little moon to enjoy. So anyway, that's some of the characteristics of Mars. You can see it's got some things like the Earth, but some things quite different and not quite designed for life. And so all of this, as we look at these different planets, it reminds us that we really do live on a very special world. A world that, according to Isaiah 45:18, God formed it not to be a waste place, He formed it to be inhabited. And these other worlds, not quite right for life. Mars is the closest, but even it doesn't have that protective magnetic field that the Earth has. It doesn't have the right kind of atmosphere. It doesn't have liquid water. It doesn't have those characteristics that are necessary for life. And that just reminds us that we really live on a special planet.
God designed all of the planets, but He fine-tuned Earth, didn't He?
He really did. In fact, if you think about it, God took one day to make all these other planets and stars in the creation week. 5 of the 6 creation days are working the Earth, making it right for life. Not that God needed time, of course, we understand that. But I think to show the Earth's special significance.
He was teaching the importance of that, yeah.
That's right.
The intricacy of everything that has to be fine-tuned to make life possible.
Exactly.
Is an amazing thing that nothing else you look at has.
That's right.
Yeah.
That's right. None of these other planets exhibit quite those features.
Very good.
Yeah.
Well, where do we go from here? How do we wrap this up?
How do we wrap it up? I think we just want to remind people that there are 4 planets that are the inner planets that are Earth-like. And we've seen Mars here. We've seen that if you land on one of Mars's moons, you get a spectacular view of Mars. We've seen that Mars is similar to the Earth in some ways, but different in some ways. And the similarities remind us that that God is a God of unity, but also a God of diversity. And so what we see in these inner planets is exactly the characteristics that we'd expect, given a God of diversity. And by way of contrast, and maybe as a little bit of a preview into another program, I just want to contrast this with one of the outer planets, Jupiter. Because you see, these inner planets are Earth-like. They're called terrestrial, meaning Earth-like, because they are similar to the Earth in the sense that they're solid, they have a surface you could land on. If you could somehow protect yourself from the heat of the inner planets or the cold of Mars, you could theoretically stand on these worlds. And that's very different from Jupiter, for example. Jupiter's a ball of gas. There is no surface on Jupiter. You could not land on Jupiter.
Surface.
Yeah.
Could you fly through it?
Theoretically, you could fly through Jupiter. Now, the gas gets very, very thick and it becomes liquid at some point, and so it'd be like going through molasses. But theoretically, you could do it.
It never gets solid.
Yeah.
That's amazing.
And so these outer planets are very different from the inner ones. And again, that reminds us of God's order, His unity, and His diversity. We have these planets that are like the Earth, unified, and these planets that are very different from the Earth, very diverse. And that's characteristic of the God that we serve. It's something that's built into the universe, and into life for that matter. The different kinds of life forms that we see on Earth, the fact that we can classify them, into kingdom, phylum, class, order, and so on. People think, well, that's because of evolution. That's why there's similarities and differences. But you can't argue that with the planets. The planets did not evolve from a common ancestor, and yet they exhibit similarities and differences. And so that's exactly what we'd expect given the God of creation, the biblical God who made each of these worlds and designed them to ultimately to reveal His glory, to glorify His name, and for our enjoyment, I think, as well.
I think you're right, for our enjoyment. I'm going to ask you this. We have a minute. Are we ever going to go to Mars? I don't mean you and I, but
I'm not.
I'm not either.
Some people it might be possible for people to go to Mars. It is a goal. There's I think it's the Mars One program, or they actually want to start a colony on Mars. I have to say, it's dangerous. It's very dangerous to put people that far away. I mean, we went to the moon, but the moon is close, very close compared to Mars. Mars is much further away. The moon was a few days away by spacecraft. Right. Mars is 6 months away by spacecraft, minimum.
And so if there's trouble, you lose those people.
That's right. And it's a terrifying thought, because human life is so precious, of course. Now, I'm not against a trip to Mars. I'm just saying there's caution. There's got to be a lot of caution, because if you don't have the medical facilities there. If something goes wrong, you got to be prepared to deal with it.
And what's the takeaway if we do? Just to sort of say we did.
There's not much. Yeah. There's the coolness factor, but there's not a lot. Yeah. Most of the science we can do with unmanned spacecraft more efficiently and cheaply.
Jason, I have to say, I love the lenses through which you look at our universe and our solar system. And I love the perspective you have that all of this really does declare the glory of God. It shows His diversity. It shows, like to make them all spin one way and one spin the other, just to have people sit around and say, I wonder why you did that. And the beauty of it all and the splendor of it all is remarkable. And I love how you see God in all of this. So thanks for sharing that with us. And folks, as we've been looking at the planets together, I hope too that it has enhanced your worldview to see God the Creator, God the Designer, God the Engineer at work in all of this. Always remember, my friend, that it's God's view that He created you. That should be your worldview too. Hope we'll see you again soon here on Origins. And until then, God bless you, my friend.
April 16, 1972. Apollo 16, man's fifth lunar landing, sat silently on the pad awaiting its mission. Inside the astronaut quarters, its relaxed crew ate Sunday breakfast. John Young, a veteran of 3 previous space flights, was commander. Ken Mattingly, command module pilot, would conduct orbital experiments around the moon, while Charles Duke explored the lunar surface with Young. April 22nd. Young and Duke would find themselves strapped into a small electric car called the Rover, bouncing across the lunar plateau known as Descartes.
The old water bag is working super. This is going to be a good day, Charlie. Yow! Woo! Man, that's a great big skid. We're doing 10 clicks, Tony. Covered me with dust on that one.
As Young and Duke rode the bucking rover to the lunar formation called Stone Mountain, NASA geologist Farouk El-Baz wrote on a blackboard on Earth, "There is nothing so far removed from us to be beyond our reach, or so hidden that we cannot discover it." René Descartes. As John Young would later remark, Apollo 16 would certainly help prove that René Descartes was right.
Compacted. Almost like a freshly plowed field that's been rained on.
Yet less than 2 days before, it looked as though this would never happen. It was, in Young's words, a real cliffhanger. The Marshall Space Flight Center team was working on a launch vehicle gyroscope problem that threatened to scrub the mission. Less than an hour before liftoff, their advisory to the Kennedy Space Center launch team was go. Had been perfect. During the 3-day flight to lunar orbit, the problems encountered had been more annoyances than critical, such as paint flaking off the lunar module, and later a jammed antenna in one of the lunar module's several communication systems. All in all, it had been a quiet flight. April 19th. The burn into lunar orbit was right on.
Oh, Houston, Sweet 16 has arrived.
The subsequent maneuvers all went without a hitch. Then the next day, April 20th, Young and Duke undocked the lunar module preparatory to landing, leaving Mattingly in the command module. The next maneuver was for Mattingly to burn the main engine of his spacecraft to put it into a circular orbit. But as the lunar module emerged from behind the moon...
No, sir. Copy, no, sir.
No, sir. No, sir. Okay, guys.
No circ. In preparing for the circularization burn, Mattingly had found apparent uncontrolled oscillations in the main engine's backup control system. Following mission rules, he did not make the burn.
How long do you think it's going to take them to get around to this, Jerry? I think your estimate of a couple of 3 revs.
With the backup system having trouble, only the primary system was known to be usable on the engine needed to get the astronauts out of lunar orbit and back to Earth. However, the lunar module engines could be used if the 2 spacecraft were docked. The first step in the problem-solving technique: stabilize the situation in the safest manner. Get the 2 spacecraft, which had separated, close enough together to dock if necessary.
Once they get them back together, get the things back that they want them, get them mentally prepared to do what they're going to do.
But now, don't take that as input. John's asking me to pitch talking out loud. I want to say something unless I'm sure.
I don't see any way we can continue on.
At that moment, the chances for a landing looked pretty slim. But you look at a problem step by step. Step 1 underway, you look at step 2. Analyze the problem as completely as possible within the time frame.
We should make sure that that's gone, but there's no way, you don't have any other redundancy or other routes.
And in lunar orbit, Mattingly flew the command module to a rendezvous as Young talked him in.
Okay, fine. Why don't you tell me what to do there, John? Okay.
Word's coming back kind of initially from North American that they're suspecting a rate feedback.
Building 45 is Jim McDivitt.
The team was coming up to speed, not only at the Manned Spacecraft Center, but from MIT in Massachusetts to North American in Southern California. Isolate the trouble, simulate it, evaluate it.
You can't use it if you get a broken wire. You don't know it's going to come back again.
Now, like I'm drifting the other way. Not according to my needles. Okay, I'll believe your needles.
Of course, then you would have had no options. Okay? I mean, then it's full speed ahead.
I just don't much see how we can make it on this next trip. I think you guys ought to continue to work.
So you'd only do it if you had a failure on the primary. Well, how would you ever get the damn thing trimmed then?
Well, I would. If I had a failure in the primary, I'd shut it down.
Well, we must be going in the right direction then. Well, yeah, you're going to get there.
Yeah, but I want you guys to go simulate it.
Isolate, simulate, evaluate. The results were coming in. It was beginning to pay off. The simulator tests and other data were showing that with the engine on, the oscillations would do no harm. Despite the earlier pessimism, it was beginning to look pretty good.
Okay, when you come up on AOS, on the next Rev 15, we'll give you a go or no-go for another try.
Manned Spacecraft Center Director Dr. Christopher C. Kraft Jr. just came back into the control center after having attended a meeting by management people in one of the back rooms, and the situation is go for landing.
Well, have at it, Dave. So we're going to try it.
You do have a go for another try here at PDI on Rev 16.
Once more, they would pass behind the moon. And on the next revolution, John Young and Charlie Duke would start their swift descent to the Descartes Plateau.
Okay, filter initialization looks good. Right on. Feel that beauty? Come on. 200. Pro. Pitch over. Pitch over. And here it is, Gator, Lone Star. Call me the thanks, Charlie. Okay, 38 degrees. Right. Down that on dot, north ray. Okay. Looks like we're going to be able to make it, John. There's not too many blocks up there. Ryan, you go for landing.
Right now looks pretty good.
Go, Hunter. Okay, any words on this?
Looking good. It looks good.
That comes a shadow. Okay, down at 3, 50 feet. Down at 4. Give me one click up. You're backing up slightly. Okay, 2 down. Stand by for contact. I'm going to let her down. You level off. Let her on down. Okay, 6%. Plenty fat. Contact. Stop. Boom. Wow!
The original plan had called for Young and Duke to get out and explore shortly after landing. However, the near abort had lasted 6 hours. The tired astronauts would sleep.
Okay.
April 21. Mission Commander John Young stepped onto the Descartes formation, 11:58 a.m. Eastern Standard Time. While their activities were monitored by Mission Control, Young and Duke were also observed by scientists, located across the hall in the Science Support Room. After unloading the rover from its storage bay in the lunar module, they planted the flag.
Hey, John, this is perfect with the limb and the rover and you and Stone Mountain and the old flag. Come on out here and give me a salute. Big Navy salute. Off the ground, before. There we go. Good.
Young set up an ultraviolet camera to provide the first astronomical observations from the moon. He took pictures of the Earth's upper atmosphere and magnetosphere and their interaction with the solar wind. He also photographed the interstellar gas present throughout space and the ultraviolet halos that appear around galaxies. Astronomers have long wanted a telescope on the moon. Perhaps this experiment would show the moon an ideal base for future astronomical observations.
You want 2 pens?
Yeah, we would like 2 pens. John, sir.
I'm not leaning on
Duke drilled a hole into which a heat flow probe was to be placed, part of one of the experiments attached to the station. As Duke drilled, Young set up the central station and the remainder of the experiments. Then, what many considered the biggest disappointment of the mission.
Probably just some rocks down there in the regolith, Tony. You know, it looks, I bet it's just like the side of that fresh crater we saw back near the limb. Charlie, what? Something happened here. What happened? I don't know. Here's a line that pulled loose. Uh-oh. What line is it? That's the heat flow. Pulled it off. God, I'm sorry. I didn't even know it.
But that means you've got to mate all those wires, separate wires in there, and have them insulated from one another. That's right. And if that doesn't occur, what are the chances of shorting out the central station? Well, that's another one that they're working.
On Earth, they tried to figure a way to fix the heat flow. On the moon, the astronauts continued with the other experiments. Young placed a series of sensors in the soil, then fired explosive charges, mapping the lunar subsurface much as geologists on Earth use explosives to search for oil.
4, 3, 2, 1, fire. Stuck in the ground and I try to get this up over the
They continued to sample the area and activate the experiments. Then they returned to the rover and prepared for their first trip away from the landing site in search for geological samples.
And here we go.
Their first traverse would take them about 1 kilometer west of the landing site. They would make 2 stops to collect samples and conduct experiments.
10529 in your flight plan.
But it couldn't pick a better spot. John, you're just beautiful. That is the most beautiful sight. What's that? You're standing there on the rim of that crater.
This guy, we're going to have to use a
Young used a portable instrument to measure the local magnetic field. He would later record the most intense magnetic field ever found on the moon, far higher than scientists ever suspected.
What's that, Charlie? It's really some crater.
As you come around there, there's a rock in the near field on this rim that has some white on the top of it. We'd like you to pick it up as a grab sample.
This one right here?
That's it.
This one right here?
That's it. You got it right there.
Okay, we copy that.
There would be one more stop before they got back to the lunar module to close out this EVA. With Duke acting as photographer and Young as driver, they put the rover through a full test.
Man, you are really bouncing.
Is he on the ground at all?
That's 10 kilometers. He's got about 2 wheels on the ground. Okay, turn sharp. I have no desire to turn sharp. Okay, here's a Sharpie. Hey, that's great. He's a big rooster tail out of all 4 wheels. And as he turns, he skids. The back end breaks loose just like on snow. Come on back, John. Okay, the deck is running. Man, I'll tell you, Indy's never seen a driver like this. Okay, when he hits the craters and starts bouncing, it's when he gets his rooster tail. He makes sharp turns.
Then it was back to their lunar base. Activate experiments and close out EVA-1.
P-wise exercise, is that right? Physical fitness, gym level? Hey, that's right. First I'll take pictures of the hot dogs. Showing the low residue, high protein diet. Anybody else?
On Earth, the scientists took a break. Tomorrow would be another busy day. April 22nd.
The lunar surface temperature in the sun should be around 135 degrees today.
Today they were headed a little over 4 kilometers south to climb their rover up the side of Stone Mountain.
Man, we are really going up a hill, I'll tell you.
Their first station, a crater 700 feet above their lunar module.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal. We really come up here, Tony. It's just spectacular. I have never seen it. All I can say is spectacular, and I know y'all are sick of that word, but my vocabulary is so limited.
Let's see what we could do. If we got that rake soil, we got certainly something. We could go to one-man sampling and maybe do it.
They would make a total of 6 stops on this traverse, collecting samples from large rocks down through the intermediates to the smallest soil particles. They would operate experiments measuring the strength of local magnetic fields to measuring the resistance of the soil to compaction.
3, 4, 5, 6.
Far away is that crater?
Man, we come a long way. Hey, John, it's easier to go straight across. That was fun. Well, I haven't had any trouble. Okay. I have a tough time walking up there.
The sampling time used up, it was time to return to the rover and head back to the lunar module.
And they did it in 2 minutes less travel time than they were pre-planned. Fantastic.
Tony, how about an extension, you guys? We feeling good? Dad, all we're going to do tonight was sit around and talk.
But with the limited oxygen and water in the backpacks, it was finally time to close out EVA-2.
Okay.
Now I think they realize that it's not more, a gee whiz, like my friend said, thrill, but it's real exploration, and this is much more serious and much more important for the future of mankind than just a plain exploit, a technical or technological exploit. This is exploration.
Ray Bradbury claims that what mankind sees in the exploration of space is his first chance at immortality since he invented religion.
Got about gifted.
April 23rd. The decision had been made not to try and fix the broken heat flow experiment because of the time and complexities involved. Traverse number 3. Today, Young and Duke would head north about 5 kilometers to North Ray Crater, the largest lunar crater to be sampled by men.
Outstanding.
Hey, Tony, it seems to me this is a more subdued surface over here than going towards South Ray. Oh, spectacular. Just spectacular. Wow. Sorry, Charlie. Beautiful. I got to keep my eye on the driving. That's great.
Jack, that's a good point to remember. All three crews now tend to think they're there before they get there. I remember.
Man, does this thing have steep walls. They said 60 degrees. Now, I tell you, I can't see to the bottom of it, and I'm as close to the edge as I'm going to get. That's the truth.
Now the routine, if anything on the moon can be called that. Test, collect, photograph. Keep moving. Time is precious on the moon.
The crater, they look like drill holes is what they look like. You do that in West Texas and you get a rattlesnake. Here you get permanently shattered soil.
How about rolling that one over?
No way.
Then, one of the most spectacular discoveries of the mission.
Look at the size of that beaky. It is a beaky, isn't it? It may be further away than we think. No, it's not very far. It was just right beyond you.
And we better press on for the big boulder?
Can't blink too dirty. Okay, we're headed that way. You get the tongs, John? Yep. I'll carry the rake.
That big black dot.
Fantastic. Right here.
If we could see to the bottom, we could say for sure if this big black rock is right out of the bottom. But my guess from the old photographs is it probably is.
Okay, that sounds like a good guess.
God, you mean they weren't at it? No. It looked like they were standing right there.
Look at the size of that rock.
Curious what they're going to look like when they stand next to it.
We can see. The closer I get to it, the bigger it is. Yeah, but look at the permanent shattered part, Charlie. On this side over here? Yeah.
And as our crew slowly we bet upon it, disappeared into the sunset.
Well, Tony, that's your house rock right there.
Very good.
Don't get too near the edge of that thing. It falls off. Look over at your right. It falls off pretty good. Yeah, I know.
Yeah, keep going.
Can't believe it. I can't even. Okay, let's go on back. I am. Be right with you.
And we encourage you just to look for some variety.
But now it was time to head back to their base and close out the EVA.
All right, we think you could just about head south now.
Yeah, the only reason.
That's it. We're going home again. Jiggity jig.
During the previous EVA, a section of a rear fender had come off the rover, causing the astronauts to receive occasional showers of lunar dirt.
And that's a beautiful sight.
Young parked the rover, then moved out to join Duke, enter the lunar module, and prepare for liftoff.
Boy, Houston, the beauty of this place is just absolutely incredible.
Smile, FAO. Don't be mad. We'll get it up there. See how nice and leisurely it's been? That's the way it should be, getting ready for ascent.
10 seconds. What a ride, what a ride. Pitch-over's on time.
Together in orbit, the two spacecraft pirouetted, each inspecting the other.
This is one of the fastest maneuvers I've made in a long time.
The inspections complete, the command module and lunar module maneuvered to docking. John Young, Ken Mattingly, and Charlie Duke, reunited aboard the command module, settled down for tomorrow's tasks. Jettison the lunar module and burn out of orbit to come home. April 25. Ken Mattingly left the confines of the command module cabin 173,000 miles from Earth. As he orbited the moon, he had not only made visual observations, he had been operating a complex series of experiments. Many of these had returned instant data to Houston. 2 had taken thousands of high-resolution pictures of the lunar terrain. Now, Mattingly retrieved the film canisters and made his way back to the cabin with them, as Charlie Duke stood in the hatch to help him. It had been quite a mission. In John Young's words,
I think we've seen as much in 10 days as most people see in 10 lifetimes.
April 27, the last day. The crew looked out their windows through the 5,000-degree fireball of re-entry at their native planet.
That is beautiful, isn't it? Now they're blooming. Beautiful. There they are. Beautiful.
Apollo Control Houston, an observer on the Ticonderoga estimates the distance from the ship about 1 mile.
You saw an example of goal-oriented teamwork in action. The kind of thing that made this country great and the kind of thing that's going to keep it that way.
At SpaceX, our primary goal is to enable people to live on other planets, most notably Mars.
It's true. They got a message from the action man. I'm happy, hope you're happy too. I've loved all that evening love, so rich and touch for the moon. Speaking of nothing's good, there's pictures of jackets and circuses. Ain't got no money, ain't got no hair. But I'm hoping dark sky is true. They got a message from the action man. I'm happy, hope you're happy too. I've loved all that needed love, so the Jesus follow me. Speaking of nothing is killing, there's pictures of jackals and circuses. Ain't got no money, ain't got no hair, but I'm hoping to get blinded, is glowing, glowing, glowing. Ashes to ashes, fire to forget. We down major toms, the junkie, strung out in heaven's high, leaving an old time loud. I'm stuck with a valuable friend. I'm happy, hope you're happy too. One flash of light, no smoking this loud. I never did good things, I've never done bad things, I never did anything out of the blue. No. Wanna relax to breathe the ice, wanna come down right now. Ashes to ashes, funk to funky. We know major toms, the junkie, strung out on heaven's high, leaving an old time loud.
because they received not the love of the truth, that they might be saved. And for this cause God shall send them strong delusion, that they should believe a lie, that they all might be damned who believed not the truth, but had pleasure in unrighteousness.